Is it good for speaker as well? 1, 2, 3. All right, people, we are about to start in 1 minute. So let's go to the stage, take your seats, and we're about to start.
Who's Constantine you're talking about?
He's here.
In the blue?
In the blue. All right. So let's go. All right. I think we are ready to start. Hello, everyone. Welcome to Decentralized RPC Summit. Let's go, clap. Yeah, this is Tom Trowbridge. Come on the stage. Co-founder of Fluence Lab, gonna help me today to host this event. Please welcome Tom.
Great. Thank you, guys. Happy to be here. Thank you all for coming. And first, I want to thank Nadia for putting on this event. It's not simple. It doesn't happen by itself. So Nadia did it almost single-handedly. So thank you very much for all your hard work on this.
Yeah, thanks everyone for coming. Let me start with some organizational moments for a while. So we're not going to have a Q&A session today after each talk. So we collecting all the questions. So if speaking presenting and you have a question to him, so please scan QR code now because then it's going to be their slides. Yeah, you put your questions like anonymously, or you can put your name on it. You can vote for the best, and then we're going to have a panel discussion after each block. By the way, you have a schedule on your badges. Take a look. And yeah, we raised the most popular ones, right?
Yep. So grab this QR code now. We'll have it in between the sessions as well. So if you don't get it now, you'll get one. You'll get a couple more chances. And I think should we go?
Yeah.
Listen, just to refresh, Tom Trowbridge, co-founder of Fluence Labs, and we just, for those of you who don't know us, we're a decentralized serverless compute network. And question is, why are we hosting the Decentralized RPC Summit? We know how important decentralization is, and we know what an important tool RPC is and how critical it is to the whole infrastructure that we want to work and to scale and to succeed. And so we think that what Fluence does, it can help you implement that decentralized RPC in a more kind of privacy friendly way without a single point of failure, and also maintaining a better areas of data integrity. And so if you want to talk about that more and talk to some more of the team, I want to introduce some more of the team. Our CTO is Dimitri, right there, standing up. And then our chief scientist is Bernard, but Bernard just vanished. I don't know where he went. And there's Bernard. So Bernard's standing up right now. It's our chief scientist. And then in the green is Evgeny, a co-founder as well. So find them to talk more about Fluence and how we can help in the kind of move this decentralized RPC ecosystem forward. So thank you again for coming. And with that, I will introduce Constantine, our first speaker, who is from drpc.org. So welcome, Constantine.
Thank you. So our topic for today is counterintuitive facts of decentralization. It's not only about this, but it's just a general thought that will be elaborate during this speech. So I'm the first speaker, as you know. Yeah, and that's why I will try to just warm up you a little bit, and we will start from pretty, I believe, straightforward question. What do you think is the most important things for RPC from the dApps developer perspective? Who think that it's actually decentralization, most important part for RPC? Come on, guys, we are on Decentralized RPC Summit, no? Yeah? Okay. Who think it is latency? A little bit better, okay. What do you want? I don't know. Okay, and reliability. Nice. Almost nobody. Just joking. So, obviously, it's not decentralization. And it is a kind of, first of, controversial facts, like counterintuitive facts. Because when we spoke with hundreds of potential clients and started with, guys, we are decentralized RPC providers, what? Okay, could we just go to, to real deal? What about reliability? What about everything else? And actually, nobody care from the client's perspective, especially right now. about just decentralization. If you have, like decentralized RPC, you will not get clients just because of that. And it is a pretty important point that like everybody need to know. So maybe latency, it was some raised hands. Also like kind of, but still, because almost everybody provide quite well latency. If you speak about Infura, for example, they work only in the United States. So basically from Singapore, from any other countries except of United States, you will get basically quite bad latency. But nobody cares. Like Infura, one of the leaders at the market. So obviously for some clients, for some depths, it is important. And from my perspective and my team perspective, it's really important stuff for the next generation of depths. But still, currently, it's just one of the good enough facts, and that's all. But reliability, it's one of the most important part. And we need to understand that our main goal here, when we speak about decentralized RPC, it's not just make it as big as possible. We need to create thousands of RPC providers connected to each other because it will be, brightest future world. It's more about getting some benefits for end users by decentralization. And it is a part of what we will discuss today. What else really important to actually dApp developers and any kind of RPC users? Actually, first one is cost efficiency. So basically price of RPC. And it's a kind of pain point because, we are trying to create the best possible product at the market. But when somebody come to you and just ask you, okay, what is the price? You can get price from the site and, okay, what about discounts? It's already discounted. No, maybe somebody can provide me this several times cheaper. Okay, maybe it will be several times worse, I don't know. It will be really bad latency, pretty bad redundancy and so on. But yeah, one of the first question, cost efficiency, what is the cost? Could you make it even cheaper? Cheaper than air, I don't know. Another one is scalability. So basically, if it's not just I don't know, startup created yesterday, it's really important to have an ability to scale resources on RPC level just automatically, without any kind of additional negotiations, calls with BD team, and so on. So basically, you just connected based on demand on your side from end users. Your infra should go with you, without any kind of tricky packages. When somebody trying to get 10 times more money from you just because in the initial package it was $50, but after several extra requests you pay $300, $500, $1K. Just occasionally. And yeah, last one, it's convenience. And we'll come back to this a little bit later, but let's focus on three main things. So reliability, cost efficiency, and scalability. As you can see here, it's just Alchemy and AWS. Basically, I believe everybody's here know that Alchemy work only based on AWS and nobody care. But yeah, it's kind of reliable, it's kind of scalable, but it's bad from pricing model. Yep, it's cost efficiency, it's quite bad here. But still, it is quite enough speaking about reliability and scalability, but only for the current level of Web3 ecosystems. Because currently, as you know, even biggest applications have small amount of clients. Sometimes it's just lower and lower day by day, and all of us just waiting for the new next billion of users. And with this kind of setup, I don't think so that next billion of users will see something on their mobile phones or laptops, just because it will be just go down and nobody care. When we spoke with several huge potential clients, they worked only with Alchemy and okay, guys, we can't just, switch to you because we already worked with Alchemy. Okay, and what? So it's just, everybody who worked for huge enterprise in Web2 world, they understand that you can't just rely on one provider. you need to rely on several providers, at least 2 better free providers. But yeah, we can add GCP, we can add Infura, so your reliability and scalability will be better, but cost efficiency will be worse and worse, like one by one. And like we can say also, United States, it's not reliable enough for us, we are in crypto, like let's add Tencent Cloud or Bare Metals or somebody else. And quick note, perfect reliability, perfect scalability, but you will lose all your money from your business just on RPC and infra. So, could we help with it by decentralization? Obviously, like why we are here, so for that. But we need to focus on quality and cost efficiency, not about quantity. Because as I said, we've seen a lot of like examples of projects who started with just, like creating decentralization for the scratch and creating, like hundreds of nodes, hundreds of node operators, thousands of node operators. And, like on the sides, you can find like we have 25,000 of nodes. We have 100K providers and so on. Why you need it? You don't need such amount of capacity. And especially, you can't work with all of these providers from the quality perspective. And that's why when we started to speak with really good companies, really good startups who already tried decentralized RPC, they told us, we kind of suspicious about decentralized solutions, and especially about decentralized infrastructure. Just because we already had a really bad experience. We started with one guys, with another guys, and it was pretty bad. And it's kind of predictable just because they focused on onboarding new providers, not on onboarding, like several levels of quality checks and providing like additional services to cover all possible corner cases and so on. Actually, who did this? Alchemy did this, Infura for some kind of quick node. All of them centralized, but they have a lot of coverage for corner cases. And speaking about quality, it is a kind of high level of quality comparable to old decentralized solutions here. So, but yeah, how we can move forward with decentralization for RPC solutions? We need to move step by step. So, as we started with initial quality checks for flat, like fair price from packages, from extra payments, from extra services, and so on and so forth. And there's a lot of hidden fees. I believe it is not a good way to get it like traction. And that's why we started with just time-proven Web3 infra providers only. For the beginning, it's good enough just because we can control quality of the nodes. And together with these guys who we worked with inside of Graph Protocol, Connex Network, Forta, other networks, we can actually move forward much faster. We can rely on them and we can create the best possible product, speaking about quality. After that, when we have initial part, we can move forward with better cost efficiency. So we can utilize resources better way. We can onboard clients who already have resources because currently, I believe like some companies who just pay you for spin up new nodes and you just get money not from request but from new nodes. In that case, it totally does not make sense just because we already have a lot of capacity in network, like tons of capacity. But utilization of this capacity, it's pretty low. So much better not to pay more and more to GCP, to DigitalOcean, and any other cloud-based platforms. Much better just connect existing nodes and sell empty resources to the network. It just allows you to make it just a more cost efficient. So it's kind of obvious, but still. And obviously, when you already have this kind of capacity and some kind of traction, you can't utilize resources, till the end of the days. That's why we also need to have several other mechanisms. For example, price auctions and price ceiling. I believe like price beats, price auctions, it's quite obvious why we need it, just because there's different providers with different setups in different regions, so they can use different price, and they want to set their own price, depends on their needs of utilization. So basically, they can use our flat price, but they can also set it on the lower level to get more requests, for example. But also, it is a kind of concerning to big clients, because big clients want to have some kind of predictable prices. So they don't want to like work only with price auctions. They want to have some kind of highest level of pricing that they can get from the network. That's why price ceiling, it's just like necessary stuff, and you can't go without it. And only when all of this is prepared and your clients get really good service, you can go to really permissionless join. Open market for everyone, but only when you have guarantees of quality, when you have several levels of quality checks. So, what we forgot? Convenience. Because a lot of guys right now struggling to find, okay, where's new rollups I can find, and where is, for example, WebSocket support, and so on and so far. And it's a really like huge problem for many devs, especially if you create something like chain agnostic or like cross-chain services. You just need to work with different RPC providers, and the worst part here, you need to pay for packages to all of them, just to get some percentage of workload for each network. So your product, your decentralized RPC, obviously should have good UX. All chains in one place, MEF protection, MEV protection, account abstraction, specific data API. Yeah, and obviously intelligent price optimization, like near real time or something like that. Because in the end, all of these big clients will just push all RPC providers to the lowest price. And that's why just like stickiness of these clients not so good, because they can just go to another provider and get better price, and after that to another one, another one, another one. So it's just like additional frictions. Much better if you have some kind of automated mechanism that will provide best possible price. And yeah, it's just like evolutionary. When you started with just free nodes, paid nodes, some kind of advanced settings when you can just choose some particular providers from the pool. But we go to quite obvious stuff. It's when you use paid nodes, especially if you're not, like pretty deep techie, you need to just get what you want. You need highest speed, like best latency. It's what we have already. Optimal solution with, like some kind of balance between price and speed. And for like a lot of devs, actually, they don't need really huge speed. They kind of fine with lowest possible price. It's just, like we are fine if it will be like 5 times cheaper, why not? So, and we need to get this chance to them, so that's why right now we believe it's a good point of time to move forward with it. So, and obviously if you create decentralized RPC solution, you need to provide as much transparency as you can. In that case, it's just examples of our interface for providers on the left side, when I believe some of you guys already worked with Graph Protocol and like GraphScan. It's a kind of similar instrument. You can find like which region, which kind of node, with what kind of competition ratio you have in the network. So it's about opportunities for you. And it should be 100% like transparent. And another example, it's about who actually serves the requests. One of our clients provides this screenshot from the personal account yesterday. And as you can see here, I'm not sure that you can see, there is all of these requests was served by 18 providers. So basically there is a pretty huge differentiation between all of these providers. And it is a really, like, speaking about decentralization, yeah? We don't have decentralized gateway, but obviously a decentralized pool of providers, it's more than just something. So my main idea here, it's decentralization, like decentralized services should be better by default to get a clients. It's not enough to be just decentralized, because decentralization itself, it's not, some valuable thing if you will not give any benefits from that to end users. So focus on what actually users want to get, not what you want to give them. And yeah, we need to build an open and collaborative community. Altogether, we need to focus on collaboration, not competition. That's why we work together with all kinds of aggregators, RPC providers, to make it much better day by day. So we created initially gRPC with p2p.org, and it was more than 10, like from 10 to 15 other Web3 infra providers. And currently we have around 20 data providers around the globe and hundreds of startups, as well as well-known names and more coming. Why it's just 20 providers? As I said, all of this, it's about money generation. It's not about, printing tokens or money from the air. That's why we need to be sure that providers connected to us get enough money to cover their expenses on servers, workforce, and so on. That's why we are trying to keep it at this amount till the moment we will create enough demand from the client side and enough quality checks. As I said before, several levels of quality checks to be sure that our final end users will get highest possible, the best possible service. That's all from my side. Let's make your dev a little bit more dev. Thank you, guys.
Thank you very much. You are early. We're not doing this normally, but because you bought yourself an extra 7 minutes. Any questions? Yes.
Hi, my name is Nazar. My question is Infura already started a decentralized infrastructure network where RPC is working as a service. How different do you consider that is with your ones?
I believe it's a kind of wrong question because gRPC already started decentralized RPC service. Infura just said that they will start. It's huge difference. But yeah, I don't know a lot of details about Infura, how it will be. But obviously, we already spent, plenty of time on creating all kind. 111, okay. So we already spent a lot of time on quality checks and rating system, load balancing system, and so far and so on. So it is a kind of complicated stuff that we created not just by small team of our startup, but also with well-known Web3 developers from Web3 infra companies. From my perspective, I believe the more we will have any kind of aggregators, decentralized interfaces, and so on, it will be better just because competition just create better solutions in the market. So I'm pretty happy if Infura will start building something and we will see pretty good products and the user can choose between all of them, or even better, use Infura, gRPC, Anchor, and Gateway FM and all of these guys, because it will be more sustainable.
I have a question regarding price and performance curve. So if we look at Quick Node, Infura, whatever, you have free tier, and then you have mostly the differentiation is by volume. And we can kind of assume that probably free tier has less guarantees in terms of capacity and so on, and latency will be worse and so on. But between the paid tiers, I don't even know if there is any differentiation, you buy just more calls per period of time. Have you seen any differentiation between price performance? If I want to buy the lower latency and I want to pay for this, do I have this opportunity with decentralized networks, or will I have it?
If we compare, sorry, if we compare like free tier nodes and commercial nodes, actually it's a huge difference. Because even in case of Infura or Alchemy or so on, usually public nodes or like just free tiers, it's not only about amount of requests. It's also about methods that's supported by the chain. It's also about geo distribution. For example, if you want to get for geo distribution in QuickNode, you need to pay additionally for like geo distribution package, like regional coverage or something like that. In case of Infura, you just don't have it. You can pay for anything, but you don't get it anyhow. Maybe in the future, decentralized Infura it will be. In case of decentralized RPC, it's just natural by default, because when you combine a lot of providers from different points of planet Earth, you get global coverage. And the main thing is how to make load balancing system, rating system, like the best possible way here to cover with like from the best latency with lower delays, with lower price and so on. And speaking about gRPC especially, we support all methods, even on like really small checks, because usually there is a lot of requests like, okay guys, we need debug and trace method. Pay like, we consume for like $30, package costs $50, but the bug trace from $200. Why we need to pay that? In case of decentralized solutions, you pay for what you actually use.
We got time for one more question, last question.
Hey, Constantine. Thank you for the great talk. I guess I think you framed the benefits of decentralization really well. I think it's really helpful for the market to have so many more options, I guess, ultimately for the end users. And I guess I'd be really interested to kind of switch that framing and actually think about it from the node operator's perspective. I guess, how much of a say do they have in the kind of the future of the network? I guess in terms of pricing power, the split between the platform, how much they're earning, I guess, just thinking about your community more broadly. Sorry, to be really clear. Yeah, just how much of a say will your node operators have a say in, I guess, the future of the platform in terms of, I guess they're providing a service, but do they have a say in how much of a take they get, or the split between DRPC versus node operators? What does that look like? And I guess, what is your community strategy more broadly?
Mm-hmm. Yeah, we charge only 20% from like payments from the clients. 80% goes to node providers. And as I said before, it's like on the current stage, especially 20 providers, it's huge enough. So if you compare, like, for example, I don't know, other providers, other aggregators, they have hundreds of providers. Yep. And even if they have biggest number of clients, each check for each provider will be pretty low. Currently, it's not, like huge money for the providers, but when we onboard all of these guys, we initially speak about, okay, guys, it's just an additional utilization of your nodes. Feel free to connect it to Blast API, POC network, Lava network. Like, it's totally not a problem. And we believe it is actually a fair point that all of these guys could work directly with customers through any kind of aggregators, marketplaces, and so on, because everybody wins from this situation. Because initially resources will be cheaper, quality will be higher, so why not?
Great. Thank you, Constantine. Appreciate it. And
yeah, just worth to mention for all the other questions, I saw many hands. Feel free to use this app, and we're going to raise them all again during the panel discussion. And Constantine will be able to answer. Yep.
And we thought we wouldn't have time for questions, but if you finish your talk early, you get to have a Q&A session. I got to say, I think the Q&A session is a super interesting part. So hopefully people finish. Harish from Covalent is next. There you are. So please welcome Harish. Thank you.
Okay, thank you everyone for attending this session. We're going to talk a little bit about decentralized read data and why it's your BFF. My name is Harish. I am the head of DevRel at Covalent. And I'm actually doing this talk in lieu of a colleague of mine, Eric. I think many of you, especially the sponsors of this event, know Eric. And he unfortunately had a medical issue, so he couldn't make it. But he put these slides together. If you know Eric, you know his humor, so you'll see some of those memes and whatnot thrown into this slide deck. Here at Devconnect, we've been hearing a lot about data availability, and in particular, short-term data availability. You got providers like Celestia and EigenLayer. What I'm going to talk a little bit about is the long-term data availability, because I think there's some interesting challenges there that are posed by, for example, EIP 4.4s that is worth talking about. We're also going to focus on a particular type of on-chain data, and specifically read data only. So Eric, he's good. He says hi. And we hope he has a speedy recovery here. So just to give a little bit of context about sort of the niche nature of the space that we're in. It's actually, this is the conversation with Tom from Infura. I think he might be watching on the live stream here. And so it's exciting where a long-term player like Infura is talking about moving their SaaS revenue on chain. So the opportunity, also alongside some of the technical challenges and the economic challenges. So this is a really interesting space to be in right now. Tom kind of alluded to this being the Eras Tour. I am definitely not your Taylor Swift here, but it's kind of a neat space to be in at this particular time. This is an interesting category to talk about. So just to give a little bit of the lay of the land, this is a space where we've had projects come through over the past 7 years. And, we've kind of highlighted Infura twice given sort of the restructure that they're going through. So it's a space that is, I would say, one of the more mature ones in Web3. And, despite the RPC interface being a standard, there is a fair degree of differentiation being presented between the various RPC providers in terms of how they highlight, how they're different. And we just saw a talk in particular highlight some of the differences. When it comes to an infrastructure provider like Covalent, if you sort of look at the stack top down, we sit at the data layer. So you've got the RPC layer, which is the read-write directly with blockchains, and then you've got an indexer and a structured data provider like us, where having sort of this structured, canonicalized schema allows developers to then pull directly from the structured database through various interfaces, whether it's a REST API or it's writing direct SQL queries. And so it's sort of this read data that we're focused on, and we'll talk a little bit more about today. Now, why are we here building infrastructure? I mean, if you take a look at all the complexities and all the challenges, some might argue it's not actually a very good business to be in. We're trying to handle all these challenges while trying to build a successful business. And so, given that it's filled with hardships, we're reminded that, there is sort of an important factor here where, Ethereum is all about decentralization and sort of presents itself in sort of a neutral perspective. But if the nodes themselves that communicate with the blockchains aren't decentralized, then it kind of defeats that purpose, right? It defeats that mission. And so that's effectively, the purpose of why we're here today and why we're talking about decentralized RPC, really in the context of this particular mission. So, a couple years of building. If you were building, a DeFi project on top of the infrastructure, you'd probably be, a lot more well off than if you were spending the last few years focused on the infrastructure. It's a very challenging space. So, we've got some tough problems to solve. And so, I highlight that we're masochists in this space, as Eric likes to point out. But there's some fun challenges here, and especially with the opportunity ahead of us with a large player like Infura moving their revenue model on chain. I think there's some really cool opportunities. So, given we provide a little bit of context around, what are some of the players in this space and some of the challenges, let's take a look at, what the current focus is. So, having talked with many of the RPC providers, here's a list of all the things that they're thinking about. And, this list continues to grow with the input from the various communities. Given all these different aspects, I think what we want to focus on from the perspective of the data layer is how we can help solve some of the storage and the read data access problems, especially when you consider in the context of value that an RPC provider offers. Really, the right data is their bread and butter. So RPC providers, they build the core infrastructure to communicate with blockchains. We build structured database. That's what we know really well. Our background in Web3 consists of individuals who've worked for IBM, for Zymeworks, for CouchDB, for Salesforce. And so it's really about focusing in on what you know, and we know databases. Having said that, decentralized read-only data, it's not the flashiest player in the space or the room. We understand that there is a key value that we can provide. And so this is highlighting the opportunity to work with RPC providers where they can offload a lot of the archival historical data that can be served up more efficiently, actually, through the services of a structured data provider like ourselves. So going back to some of the emerging trends that we're talking about here, especially with the one that has been talked about a fair bit at Devconnect, which is the EIP 4.4s. We're entering this space here where there is going to be potentially some challenges with accessing long-term and past historical data. So given where we sit in the stack, this is effectively how we see the things unfolding with respect to the different data availability plays. So you've got the RPC providers, and really their specialty sort of is underlined with the core elements of consensus, settlement, and execution, and focused on those layers. You then have Celestia, EigenLayer, and a few other players focused specifically on this challenge and providing short-term data availability solutions. And then, where we play and some of the others in this space, it's really about that long term with rollups and, many other application-specific chains coming online. I think there is something to be said about some of the challenges facing the long-term data availability play. So, the way we position ourselves, if you've heard about the internet Wayback Machine, we're the Ethereum Wayback Machine in terms of how we'd like to think about this. And so what that means then is the flow of data through our infrastructure. It starts by indexing a very broad set of blockchain data, having that canonicalized with a defined schema, and then put onto the network, which is the core Covalent databases. And then you can build all sorts of interesting application layers on top of that, where that data could be served up through APIs, it could be served up through various transformation engines, it could be served up through even just direct SQL queries, and then that powers all sorts of various applications. So this is effectively the model that we have built as part of the underlying Covalent network. And so, being able to pull data directly from the RPC, it's a bit of a messy process, and the data that you get is, it's not very structured. And so what we do is structure and organize this messy blockchain data across about 200 chains. And then what you have is this giant table that you can effectively query. And the reason for showcasing something like this is even just visually, you can see just how effective you can serve up archival data through a structure like this versus making JSON RPC calls. So if we sort of summarize what matters to us, we're having this unbundling of the tech stack, where you've got various providers that can offer the execution, settlement, consensus layers. And that's really cool because it allows for a very composable type of architecture. And then you've got a few players offering the short-term availability layer, and then the Covalent Wayback, or the Ethereum Wayback Machine, as we positioned ourselves, offering the long-term data availability play. So, because of the way this is positioned, for all the RPC providers out there, you can think of the Covalent node as being a key partner in the ecosystem. So really, from the consumer's perspective, they're focused on getting data at the cheapest and quickest manner, and having archival data provided through a specialist like us just ensures that the user is able to get some critical data at the lowest cost possible. I think that's all what we're driving towards as part of the decentralized opportunity at play here. So in this process, we're also going to be announcing what we call the fee switch. So currently, the model is set up such that you have users paying with fiat to be able to access the underlying database. But what we're going to be doing is taking that process and moving it on chain. So what that means is, the usage fees that are collected are then put into this process of buying the underlying CQT token, and that's the driver of the token. And so as you see more chains being indexed, you're seeing more data being available, more data being consumed. You get this flywheel effect, and that's effectively what we're trying to build out here as a key part of the decentralized ecosystem. So it's moving this revenue on chain through this flywheel mechanism. Now, it's interesting when I ask people, if they have any perception of what Covalent is and what we offer. A lot of the times it's just simply saying, well, you guys are just a basic API provider, maybe no different than what some of the others who offer API services have. But there's actually a lot more that we're building under the hood. And it's actually a really exciting time for us because, given what you might about the current market sentiment, it's actually never been a better year for us at Covalent in terms of helping build this core infrastructure that's going to drive the next wave of growth. So maybe what you might see is a relatively small sliver of our offering, but there is a lot more being built under the hood and a lot more coming to market next year that we're going to be really excited to share. So in terms of how we can collaborate, there is this channel partnership sort of process that we've set up with RPC providers. So being able to offer services through Marketplace. We've got a pretty exciting announcement with a Gold Rush toolkit that we are going to be releasing, I think, effectively tomorrow. And so if you want to basically build out an extension of your product that allows you to pull on-chain data, you'll be able to do that through this tooling. And then in terms of the network itself, we are onboarding various players to basically be able to run a node as part of the Covalent network. And so there's a CTA there where you can get involved and be a part of that read data infrastructure that we're really excited about. Okay, that was basically it. I think I'm probably maybe ahead of time here or not, but
we've got time for questions. So okay. Excellent. Well, this is best part. Do we have any questions here? No. Oh, yep, we got a question. Great.
Hi, my name is Nazar, and I was looking on one of your slides where you mentioned the light client era, and based on the slide, it looks like you think that the light client era is over now. Why do you think like this? What's your analogy behind it?
Sorry, you were saying the light client data?
There was a timeline slide where you mentioned that the light client era is finished. Back.
I hope this is a question I can just blame Eric for, but let's see.
Yeah.
This one.
Next slide. The next one.
Oh, yes, this one here. Sorry, I'm seeing it on a different one.
Next. Yeah. So you mentioned the light client era 2017 till 2022.
So I don't think it's like necessarily like a fixed sort of time bucket here. I think what we're talking about here is with the light clients being predominantly wallets. You know, that was sort of the first wave of tooling that helped drive this sort of process to be able to read and write data, so being able to write transactions to blockchains through the wallet interface. But that's no means to say that, you know, just this wallet interface is going to be the only one that's there. You're kind of just seeing an evolution from that. So probably capping that within a time frame is maybe not the right way to frame this. But okay. Thanks for pointing that out.
Thank you.
Great. More questions?
Yes, so with the Ethereum Wayback Machine and the read-only database that you're building with Covalent, what kind of new use cases or dApps would that unlock, and what ones does excite you the most?
So so what we're excited about in terms of some of the use cases that being sort of established as the Wayback Machine we're able to offer. Is that the gist of the question there? I think what we probably think of as exciting is maybe not what the general population thinks about as exciting. I think some of the key things that we're seeing right now, especially as a key provider of historical data, there's actually been a jump in interest from both the digital asset service use case, which includes everything from accounting to forensics, to taxation, to risk and insurance. And so in all those cases there, you know, there is a need to be able to go back to the very beginning of, let's say, a wallet's sort of transaction history, and then be able to piece together the story of their activity. You know, there's probably a very prominent bankruptcy case that is underway, and so we're actually offering the data as part of that process, because there's something like 10 million wallets where data going back to the Genesis block needs to be fetched across every chain that wallet may have been active with, and in terms of that process, it's not super easy to do that through an RPC. Like, you'd have to go chain by chain to be able to do that, whereas through a structured query where everything's in a single table, you can effectively get all the activity for a wallet across every supported chain with essentially one query. So that's sort of the advantage that having a structured database like we offer, we're able to provide to those specific use cases.
How are you doing? Could you share any more detail on the fee switch and how it's going to help with the flywheel?
Yeah, let me see what we can talk about here on that. So I think the fee switch, which isn't uncommon to what we are offering, I think there's a few other ecosystems or projects in the ecosystem that are offering this. But the idea is that you have right now a decoupling between sort of the user engagement of our data and the actual underlying token that is supposed to be, a key part of the network. They're completely decoupled right now. It's just like this governance token. And so the idea behind the fee switch is you want users of your data helping to drive value in the underlying network. And the way that that's going to happen is if there is this coupling where users paying for data then drive the value mechanism for CQT, which is the token. So what that means is, under the hood, you will have this buyback mechanism where whatever fiat currency is used to purchase data is then used to purchase CQT to then drive the value there. So that's effectively what the fee switch entails.
Any more questions? We've got time for one more. No. We are questioned out. Okay. Well, with that, thank you, Harish. Appreciate your
thank you so much for your time, everyone.
Sponsorship. Thank you. Once again, we're going to pull up that QR code for everyone to put in the questions you were too shy to ask publicly. So put them there. And we're looking for Rick from HOPR. There we go. Fantastic. So please welcome Rick Krieger from HOPR. Thank you.
Okay. Okay.
Perfect. Thank you. Hello, everybody. Hello. My name is Rick. I am co-founder of HOPR. Today, not wearing yellow, but whitish, colorish, because in order to showcase what HOPR is capable of doing, we started a year ago at DevCon in Bogota on a small hackathon project, the first distributed/private RPC provider. Why? Why not, as we say in the Web3 space, but let's get there. So, in order to know a little bit better who I'm talking to, because now you know me a little bit, who am I talking to today? Who is from Turkey? And who is from the rest of the world? Okay, good. Everybody's here. That's super cool. Thank you very much. Who is less than 3 years in the Web3 space? Only OGs. Wow. And welcome to the newbies. No, that's super cool because we're all here since not so long in terms of Mother Earth, relatively shortly, but it's really good to have you. Who is coding? Okay, and who are the economists and other marketing dudes like me? Okay, good. Welcome to the club. We need everything. But the most important question is, when we started at one or the other point of time, and that's, I believe, which is amazing that you're all here in a bear market, so I guess you really want to build something and not only ape into anything, which is also interesting, that's fine. But the reason why we really came to the Web3 is maybe because we didn't like some parts of the Web2, or we thought like this can't be it, or this can't be final stage. And the reason why we came here is freedom. And in order to reach freedom, not only on an island where we believe that we're free, but in order to reach freedom from a technical perspective, we need to be censorship resistant, and that means we need to reach a status of credible neutrality. It's pieces of the infrastructure which should be a little bit more or properly decentralized and currently is not. There's a few ones who really started it. We're talking about RPC providers in general. I think it's a really complicated movement. It's not something easy to do over the weekend. Otherwise, everybody would have already done it. On the other part, I think it's important that this will finally be becoming reality. Why? Because in order to anything on chain, no matter what you want to do, you want to buy, sell, swap, ape, vote, delegate voting right, you need a wallet, and a wallet needs RPC calls. None of that, nothing on-chain happening, at least for dumb people like me who don't really understand to code the shit themselves. And in order to reach that state, infrastructure needs to be decentralized. But if you think of it for a second, we're having this ugly Web 2 world where everybody is harvesting your data. But compared to AWS and Google, who at least partially tell us, or the people who are working for, what they're doing with your data, imagine you have a really properly decentralized world. Cool. That means that every one of us is running minimum 1 or 2 or 3 nodes. Okay, that means not only the good people in this room are running some nodes, but also maybe, you know, the weirdos from our neighborhood. That means that maybe some people are running nodes where we wouldn't trust our freaking data, because they wouldn't maybe tell us what they would do with it. Intended or not intended, whatever it might be. And that's the reason why I believe that it's important to not only have decentralization, but also privacy. Because we don't want to show everything to everybody. And personally, I believe we should have choice. I think it's important that for some data you say, no, I don't care. for whatever reason, because you want to do that the way you want. But for the other reason is like, maybe the other stuff I'd like to protect because I don't know what's coming next, or because it's my personal data, it's my medical data, it's my transaction data, it's whatever it is. It's not only crypto transactions, but I want to protect it. And I don't want that everybody is, by harvesting my data, by looking at what I'm sending at what time of the day to which IP address, is going to be protected at its best. And this is exactly what we're doing at HOPR. That's the reason why we're talking about why RPC providers shouldn't be only decentralized, but also private. There's one thing which is a little bit strange, and I think that most people of you might already know it, but I'd like to talk about it for a minute, because I believe it's not properly talked about in the last years. And in September, I was invited from a wonderful friend, Francesco. He organizes builders, because when we're talking and when we're coding and when we're working on and on in our environment, and we're trying to focus on decentralization, maybe other things get a little bit lost. So let's quickly talk about this. When you touch your phone, when you touch your desktop, it's all super, super cool. Fine, here. When you touch your phone, when you touch your laptop, you are interacting with various companies, if you like it or not, one or the other way. And this data needs to be magically sent around from your device to whatever Google. And even if you're not on Facebook, we all know that somehow they get you. And in between, there needs to be a transport layer, you know, this magic stuff which flows through the air, which nobody is able to see. That's the amazing transport layer. And when we're talking about what we're having in the Web3 space, it's exactly the same. So there's an amazing decentralized application. There's many, many people on working many, many interesting and very important stuff. And then there's the blockchain, but somehow this stuff needs to get from left to right or from right to left. Agree? And this is exactly what Vitalik said and what Vitalik is talking about. And we talk about off-chain. And that's exactly what we do at HOPR. The stuff needs to be sent from left to right. The stuff needs to go somehow through whatever. T-Mobile, Swisscom, whomever it is who's sending your data, AT&T, Vodafone, in order to do that. And HOPR is the transport layer, the off-chain data layer in order to send your data. You could encrypt your data. Absolutely agree, would be super, super cool. But if you think of it, or using a VPN, and we come to that in a moment, and if you think of it, it's a little bit like, it's a nice start, but maybe it's not what you want. Christmas is coming up, and there's going to be many, many parcels under the Christmas tree. And if you want to be really, really good in already guessing what your auntie and uncle are giving you for Christmas, here's one tactic. It's like encrypting your data. If you stand at the DHL conveyor belt here in Istanbul, and you look at these packages for a certain period of time, super cool. And then you start to unpack these packages, you start a huge axle, and then you're like, okay, this and that size, coming from this and that region, going to this and that region, sent on whatever Mondays, blah, 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 blah. It's that weight and all that stuff. So gathering all the data, unpack it, look into it and say like, okay, good, tennis rackets, fine. If you do that once, you know one packet. If you do that 100 times, you know 100 packets, and maybe you can already relate to, yeah, we had that color like a few packets ago. If you did it 10,000 times, you get really good at it. And I think after a few million packages, you know exactly what you get for Christmas. Now, if you think of that in a data environment where you are sending your data on a daily basis with your cell phone and desktop on and on and on, because how many moments in your daytime you're not touching your phone or your desktop? Imagine that not me are doing it, but that some amazing machine is doing it. So encryption becomes really lame, right? Because you know exactly, when you look at the metadata of the data, what's happening next. Like this person is sending, again, messages to his mom. Fine. Arguing again. They all know that. They don't need to look into the data anymore, and that's what NSA Director Hayden said, like we're killing people based on metadata. Sounds like a lame saying, but this is exactly what it is. Why should they decrypt all the shit when they already know what's going on without encrypting it? And this is exactly why we started to build infrastructure for privacy. Let me quickly explain what we were doing in 3 quick slides. So the first one is If you use a VPN, it's all nice, you get a different IP address. So instead of your IP address, you get a different IP address. Doesn't make it much harder for any attacker to attack you, but hey, you have a different IP address. So it's super cool for streaming any cool videos out of the US, where you want to make Netflix or any other streaming service believe that you're in the US and you get the stuff. Okay, amazing, that's super, super cool. Anyways, everybody is still able to look at your metadata. Encrypted or not, still the same. So one of the things which we are changing at HOPR is we're taking your packet, we're splitting it up into many indistinguishable packages. We call it the yellow HOPR balls. They all look exactly the same. So from the outside, thanks to Sphinx packet format, nobody sees a difference, no matter if it's your packet or yours or yours or yours. And then we mix them, throw them into our network, and that's it. The second part is none of these packages. So if you have a message, it might be whatever, 10, 20, 30 balls. None of these packages is routed via the same route. So the first one goes through the one in the middle, the second part of your package goes through the third one, and so on and so on. And at the end, the receiver, after one or two or multiple hops, it gets reassembled at the destination where you wanted to send your message, no matter what it is. So it's different to any VPN, and it's much more complicated in order to know who's doing what with whom, because none of these players in the middle know where the packet is coming from or where it's going to. And if you would look into this packet, if you would decrypt it, then you would maybe find from a text message half a T. What do you with half a T, a quarter of an O, or a full A? Might be part of a message, might be part of whatever. The second part is that we're doing mixing at each of these nodes. So it's not first packet in, first packet out. So whenever Rick is sending a packet, then it's not the first one in, the first one out. We're sending it in, we're mixing it with other packages, we're mixing it with cover traffic, and at the end of the game, this gives superior privacy to whatever is existing right now. Because you can't observe the entire network in order to see who's doing what with whom and then reassemble it. If you mix it at these nodes, then it gets really complicated. And the third one, and this is our home-baked USP, if you, for example, decide that you would like to support privacy, you're able to run a HOPR node, and every time somebody sends a message from A to B and you're relaying the message for these people or parts of this message, you get paid in HOPR token. And that's the reason why we believe it's not only better decentralized, but it's also scalable. Because whenever people are able to make money, then usually they might think about running a node. Now, back to the Web3 space. Data harvesting in a Web3 space exists, yes or no? Who thinks that yes? Who says no way? Okay, good. We're on the same side. We can skip the next 5 slides. No. The scary part about it is that, I mean, it's all obvious we're talking about MEV. The scary part about it is that in the last 12 months, MEV costs every citizen of the Web3 in total over $1 billion US. That's guesstimated. Okay, good, fine. So it's costs. Currently, it's not very advanced. I mean, yes, searchers are starting to look at the mempool data from CowSwap, but this is still, you know, early shit. We're nowhere where the Web 2 is. But we're getting there, because currently it's not very automated. And MEV is, I would say, lovely. Because MEV just wants your money. Simple as that. AWS, Facebook, and others, they would like to know a lot more about you because they want to, or they're able to sell you any other shit. They want to know your religion, where you come from, if you have 1, 2, or 3 kids, your sexual orientation, your preferred holiday destination, or whatever they would try to sell you. MEV just wants your money. Your money, my money. But if you start feeding this moloch of data harvesting, it wants more. It doesn't want less. Where did we get in the last 20 years in the Web 2 space? Now the question is that our vision and are we all fine with it for the Web 3 space? Or is there another option? So, of course, the solution would be Hopper. That's what I'm saying here as a co-founder. And that's exactly why we started to build RPCh. And because I simply want to choose myself if I would like to share everything with everybody on planet Earth or if I would like to protect it. And I'm not only talking about the picture of my neighbor's kids, which I think is none of the other businesses. It's also about my crypto tokens and coins, which I might have or not, or whatever. I'd like to decide for myself. I'd like to live in freedom and decide for myself what I would like everybody to know and what not. What I would like to share with the world, where I don't care, what I care, whatever. I simply would like to take a decision by myself. If you want to like to know how bad this really is, and if what I'm telling you here is half or fully correct or even scarier, if you don't want to have it scarier, I tell you don't not look at it, because it is a little bit scary. Derp is the, as we called it, dump Ethereum RPC provider. It's able to show you what your wallet is exposing. And this is not against wallets. I truly love wallets. I think they could do one or two things more and a little bit faster, but I think that it's also maximum complicated for wallets to do anything. Why? Because, yeah, it's hard for them to make money. And if you're not earning a lot of money, then I think it's problematic to get really good developers in order to, you know, evolve your product. I personally believe that the wallets are the opportunity for mass adoption, but on two sides, not only on the user side, also on the developer side. Here I would agree we could use more people from really good Web 2 UX teams in order to, you know, not only make it a little bit easier for everybody to interact with it, get rid of some bugs, but also have some scam protection, fraud protection, privacy features built into the wallets which people do not understand, like HTTPS, but which are just there in order to protect you. And Derp will show you, if you run it with your wallet, what's exposing. Only you're able to see the data. It'll show you how many tokens and coins you have. It'll show you how many wallet addresses you have. Yes, it will. Your wallet is showing all the wallet addresses which you have, and it's also linking it to your IP address, which at the end of the day is where everybody is able to attack. And that's the reason why we started RPCh over Hopper. So all the RPC calls are sent through the Hopper network. The setup is relatively easy. Currently, there's two options in order to use it. The scenario, how we would like to see it being implemented, is that we're having this wallet SDK, which every wallet is able to integrate it. Then the second part is we have, just like Ethereum, we have 3 whitelisted entry nodes, which are there in order to operate your RPC call. And then we are running or routing all your RPC calls through the Hopper network in order to add privacy to all RPC calls. And then you can pick and choose your preferred RPC provider. Best case, of course, our preferred partners like Gateway, Allknows, Blast, Nethermind, and so on. And they bring it on chain. Currently, this version is live for ZK EVM, Ether, Ethereum, and Gnosis. And now let's see if this is half working. No, it's not. Then we leave it as it is. For you, as a developer, I guess everybody of you is able to run a Docker. If you're able to run a Docker, I have a little present for you. So you're able to download at degen.rpch.net our RPCh, download the Docker, run it in the Docker, and then you're able to use it on the 3 preliminary chains. Or if you were able to set your own chain, your own local host on MetaMask, for example, you're able to use it in the wallet of your choice, the wallet where you're able to set your own RPC endpoint, all the calls via RPCh. And with this code, you get the premium version for the next 6 months for free. Try it out. And the funny thing is, if you really want to challenge it and see if it's correct what we were promising to you, use your wallet, run derp, see what's exposed, install RPCh, and then have a look at derp again. Good. I wish that we are not only onboarding 1 billion people, end users who are throwing in money into the game and everything is going to be funny. I wish that we were onboarding minimum 50% of this billion users, developers and startup founders, people who truly understand what the Web3 is about, who are educating more people, who are giving more people the opportunity to work in the Web3 space, especially in this environment and in these times. And I truly wish that one fine day we're going to have a absolutely fantastically decentralized infrastructure where privacy is at least a default setting or an option you're able to pick and choose everywhere in order to have this massive opportunity for everybody, not only us. I mean, looking at us, we're all sitting here. We're all relatively fine. At least we're healthy. We could afford to come here, even if it was just, you know, the bus. There is many people out there who do not have this opportunity. And sometimes it's not only about swapping tokens and coins and buying and selling NFTs. Sometimes it's about having cash in your pocket, and that's the only opportunity for you to save money. And I think this is something we should solve until everybody on planet Earth is able to make a better living for him or herself. And that's exactly why we need to work on the infrastructure and make it available for everybody. Thank you very much.
Terrific. Thank you. I think we've got time for one, maybe two questions. Do we have any questions? Yes, we have a question. 1 second. Let me get you that mic.
Hello. My name is Ahmad from Forecash Exchange. In your speech, you said you split the data to the same packet, and you use a different route to deliver the packet. So how could you combine the packet again and rebuild the actual data?
I'm the economist, I'm not the developer, but everything is open source and very well documented. That's one of our secret ingredients, and that's one of the biggest problem which we had really in the beginning, because you want to split up the package, the package needs to know where it ends up. And this is what we partially do with the unknown format, where every time a packet gets relayed, one layer gets exposed, and the last layer is the final destination. And then within that header of these packages, the assembly or the reassembly is defined. Does that half answer your question from a non-techie? Yeah.
Great. Any more questions? All right. Listen, thank you, Rick. Appreciate it. And everyone, look. There you go.
Thank you.
Thank you, Rick. Appreciate it. And everyone, we have a panel coming up. So everyone who is just speaking is now going to be up here on a panel. So we're looking for Igor, who is going to moderate this panel. Come on up, Igor. And then we will get everybody back up here to engage in the panel deeper discussion here.
Yeah, just give us a couple seconds to set up the stage. And still we have time to drop some questions to this panel. Yeah, and we're going to discuss it.
Are we going to...
All right, is everybody here? Good.
Yeah, hi everybody, I'm Igor and I'm moderating the panel today. So with me there are 4 amazing people who will chat a little bit. I have the new school questionnaire here and the old school questionnaire here, just in case the technology doesn't work. But at first, let's go with the introduction. Let's start with Peter.
Hi, yeah, I'm Peter Stewart. I work the head of infrastructure at Anchor. So looking after RPC nodes and various other things, advanced APIs and so on for Anchor, with my team, obviously.
My name is Constantine. I'm CEO of grpc.org, previously head of product from p2p.org. So, yep.
We need to share one. Hi, my name is Rick, co-founder of HOPR and RPCh.
Hi, my name is Dylan, and I'm one of the engineers who will be leading Covalent's decentralized RPC solution.
Cool. Thanks, everybody. So, yeah, I'll start with the questions that were asked by the people in the audience on Slido. There's not that many of them, but we'll probably start with, let's start with the RPC. So, you mentioned in your talk that there are many levels of quality, how you assess the node providers. It looks like aspiring node provider wants to figure out what exactly these levels of quality that you're checking.
Yeah, currently we have kind of like intelligent load balancing system. It's not, obviously it's not enough for quality checks for somebody who just joined to the network, because like how it works right now on the pretty high level. If we get a request from some dep, we understand it on the Cloudflare, what is the geography for this kind of request. And after that, we look at what kind of method called and what kind of providers, what kind of node inside of this provider will be the best one for that. And we can't rely only on historical data because, for example, like 1 hour ago, it was pretty good node. Right now, it's overcrowded, overloaded, and it does not serve your request well with the best possible latency, for example. Or maybe there was some like kind of fork on the chain, and 5 minutes ago it was okay, but right now it does not working at all. And that's why we need to have some kind of new real-time rating, and we estimated around 1 second. All our providers estimated around 1 second, and it doesn't make any kind of delays to the requests, but still it allows us to, cut huge part of potential dangers here, potential risks. Another part, it's just a public library called dshackle. We with Igor already discussed about it more than 1 year ago, and we rewrite it like really heavily since the time. And currently, it solves a lot of problems, and it's totally open sourced. You can look at it, you can use it inside of your infra. It solves actually a lot of problems. It's checked like all the chain heads, errors, and so on. So basically, it is a good enough for at least centralized providers and a small group of providers as we have right now, like around 20. But still, if we speak about permissionless join, it obviously will be not enough, just because if somebody will join and especially will create, 100 providers, and it will be high risk to get even just occasionally to get request from some dev. Even if we will decrease in rating this kind of provider, our users still get a better response on the request. After retry, he also can be served by another malicious actors. So basically, end user will get pretty bad user experience. That's why we plan to implement several levels of checks here, where on the first stage, around 1 month, all our new providers who apply to the network will be connected only to public tier and will serve requests as a public goods for users who, like early stage startups, just occasional analytics or something like that. And there's a time that actually malicious actors can't allow to spend on this, and there is just enough information for getting some kind of footprint, if I can say like this, fingerprint. And after that, move to next level of quality checks. But next level, it will be just like a middle between first and existing ones. It's more technical thing. There is more for I don't know, future publications, because currently it's just kind of conception. And our CTO just writing it down, and I believe we will publish to these guys from the network, from the community, maybe early first quarter or second quarter next year.
Yeah, thanks a lot. And then continuing on this, I wanted to ask Peter a little bit on the other side. So you mentioned a little bit of malicious actors. So what could be the dark side of the decentralization of infrastructure?
Yeah, I mean, I think it's maybe a misconception about us. We are actually decentralized in a similar way. We do have multiple providers, actually, at least for most of our larger blockchains. And yeah, it's a huge challenge. I'm not sure we worry so much about malicious actors. I think that's a fairly hard attack to do. Certainly, we are worried about people doing MEV on transactions, which I think you mentioned during your talk as well. So it's really about protection of the user rather than really believing that somebody's going to have a node that's got a completely different blockchain or so on. But yeah, we've been decentralized essentially from the start in terms of even when we integrate new blockchains, we have the foundations providing their own nodes and so on like that. So we kind of accept that they are trusted actors within this. But yeah, we would like to move to a decentralized future, or we call it a distributed future, rather than decentralized, because we still have a major centralization point within having a single domain and all the rest of it. But yeah, this is the main thing that we look at is in terms of maliciousness. I think it's a fairly hard attack, actually.
It's interesting. And also, I wanted to ask a little bit, Rick, what's your thoughts about, again, if we're looking at right now, like RPCh works with just like a handful of providers, right? But then if we look at the even more distributed future, what could be the extra privacy implications on that for the customers?
So the basic idea is that every RPC provider, I think it's, so personally, asking me personally, privacy should be default, fine. The world does not what I want, and I truly believe that it's important that there's a choice. I think not having a choice is always not good, because you don't know what the user or the developer would like to do with it. Even the RPCh setup will have an option to run your RPC calls as a wallet through the platform by using HOPR and by not using HOPR. Not because I personally think it's not necessary, but I personally think it's important to give that choice to the user for whatever they would like to do, for trying out stuff. Next steps in terms of your question on privacy is that we need to scale HOPR in the background. in order to become really, I mean, currently we're just having 350 nodes. We're scaling it by the end of next year to a few thousand nodes, but I think this is going to be the most fundamental part in order to put RPCh on a fundament that makes it easy to scale.
Yep, thank you. And then one more component of everything, like we talked about the privacy, we talked about the default RPC, but there is also indexing involved, and it's used in a lot of projects. And what are the key considerations, let's say, for the decentralization and challenges with decentralization of indexers? That's a question for Dylan.
The question is some of the key challenges for decentralization for an indexer.
For indexers in particular.
Yeah, so there's a few things to think about there. So when you go to an indexer, you are trusting that the data, or you hope that the data that they're providing you is as secure as the data that is available on the blockchain. So as an indexer, at least at Covalent, we are striving to maintain that security as well. So the Covalent network has a whole network of validators, and these validators work together to come to consensus that the data that the Covalent network is indexing is in fact correct, and the proofs are submitted back to the network to prove that the data is correct. So to improve that accuracy over time, we just want to grow our network of validators to ensure that as we're indexing data over time, that the validators can always be in agreement that this data that we are ingesting is in fact correct.
Yeah, thank you. And also one question from the audience is that, but what will you do to make on-chain payments to Covalent fast, basically, if it does per request, basis?
On-chain payments to Covalent?
Yeah, well, when you have to, I mean, it's mentioned that's how the payment process could be implemented on a per query basis on-chain. Will it be too slow?
Will it be too slow?
Yes.
So the architecture for that is still in the works, but it will be very similar to how other per query providers work. This won't be settling on Ethereum. There'll be our own chain system for handling the per query payments. But yeah, don't worry about that. That'll not be a concern for paying for the API in the future.
Okay. One more question that's probably for everybody is we mentioned a lot of geographic diversity, a lot about different players like organizational diversity and stuff like this. But also one more important thing that's Ethereum Foundation usually cares about and stuff is the actual client diversity and implementation diversity. What are your thoughts about that and what it could bring to the table in terms of this? Yeah, we'll start with Peter.
Yeah, I think it's a really valid point. We do have, in general, a reasonable amount of client diversity. We don't run absolutely every client. There's a range of reasons for that, mostly about performance. A lot of nodes perform similarly on a consensus way, but in terms of the RPC performance, there are massive differences. And when you're serving as many calls as we do, we're up at 200 billion a month in terms of the number of calls. We really have to optimize. I mean, even if it would be nice to have a greater diversity of clients, the economics don't really work for that. We have to run the things that are the most efficient for RPC queries.
Yeah, I totally agree that it's not let's say, suboptimal to use all of these kind of clients, but still it's really important to do that at least for some % of your workload, especially in case of Anchor, because as you said, there is a pretty huge workload and you have a lot of different clients, different types of workload. So it is really important, and I believe it's really underestimated how valuable could be feedback from any kind of RPC providers who use different types of clients to clients developers. Because we're also in touch with all of these guys, and sometimes it's pretty unpredictable problems with some corner cases. And if everybody will use something that just cheaper or just faster, and okay, that's all, we will use just this one. It will be a problem, because when something happens with this particular client, everybody goes down, and this is a price that we need to pay. Obviously, we can't pay this price, for equal amount of like equal percentage per each client. But still, we need to have some kind of system to send some percent of the workload, estimate how good or how bad it works with particular method, because as far as I know, there's a different methods works differently with different clients.
Tracing.
Yeah, especially. And we can get like pretty different results from that. And timing for that also like pretty varied. So yeah, I believe we need to support this kind of like efforts and have diversification of the clients. But yeah, obviously not like in the equal percentage.
Yeah, why not? No, so HOPR is ready. We're live since a year. We're onboarding the first use cases and customers. So more diversity is for us, more clients. That's always fine. Don't misunderstand me. But the reason why I said why not depends a little bit on where we want to go. I believe that, and I guess everybody here will agree with me, RPC calls are standard. None of you is... Yes, I mean, they're faster, more decentralized, better, nicer, lower in price, whatever. But if I understand everybody correctly, that's not the core what you're currently doing. I mean, you start with RPC calls or you're doing RPC calls on the side, but that's not the core what you're doing. There's way more interesting stuff out there, and B, there's way better margin business out there. So and that's where I want to go. So I think it really depends a little bit, and client diversity is important, but I think it really depends on what the client wants. Sometimes the client maybe only, wants something fast, cheap, decentralized, that's it. And then you're like, okay, let's like all of you did. Let's have this department, it's doing this what it should, really, really good, improving on a marginal level because we're already at 80%, that's blah, blah, blah. But then on the other side, maybe you also establish a department where you say, okay, good, let's go further, let's explore in different spaces, let's go somewhere else. So I think it depends on what the client wants. Just to say something different.
Yeah, so from Covalent's perspective, the services we provide, Covalent is going to be providing read RPC requests, and we'll be partnering with other providers who run the full node who can offer the right to the blockchain as well. So from our perspective, the client diversity is good for the end user, but we're just really going to be focused on making sure that our requests match the standards of the node provider that we're partnering with.
Yeah, Gateway does run a lot of different clients, and especially, on both staking side and the RPC as well. And we try to run minority, especially in the staking side, because but we need to also reach the quality standards. Let's say if you are in the liquid staking pool, you don't want to be the worst provider in the staking pool, but the most opinionated one, just because. So we also, trying to do this. And I think the biggest pain on this is actually on L2s right now, when client diversity is sort of non-existent, and you get what you get. And also one more, those who run.
Well, you're working at least on one L2 that.
Oh yeah. We're trying to. It's not officially, we teased it a little bit, but we're trying to bring client diversity by adapting the Aragon client towards Polygon ZKVM. So at least it will have it. I think Optimism also has an Aragon implementation, and that's about it, right? But also, I think one more pain that I want to mention, that's this ish in standard ish JSON RPC is really bad, really, because you cannot mix for the same API request. You can't really mix different node types. You may be okay, we send all the ETH get proof to guess, and then every tracing is on Aragon, and let's say subscriptions on Nethermind. That's what roughly we are doing there. But we cannot do half ETH get proof to guess and half onto Nethermind, because the results won't match each other. But one more question that I wanted to actually ask is, I think we can, it's more related to Covalent actually, is that we always had this notion of permanent data on the chain, but then right now with the new things like state expiry, with dunk sharding, with blob transactions, it started becoming a little bit more ephemeral. So what are your thoughts on that, and how maybe proper decentralization can help with that?
Yeah, so this is a problem that Covalent's really excited to solve in the future as this becomes a bigger and bigger trend in the industry. As a read and database focused company, we are really set up to address this problem of data availability. We're starting to attack this problem by serving these read JSON RPC requests, partnering with a node provider. But as the Covalent network continues to evolve and is built out, we'll be able to have proofs for all the data that we're indexing, as I mentioned before, is valid and correct. So while this data may not be available on the blockchain, it'll be available through the Covalent network, and you'll be able to look up the proofs for that data to ensure that the data you're getting from our network is in fact valid. So stay tuned in the next couple years as the IP4.4 progresses, and hopefully Covalent can be one of the providers to address that problem.
Cool. Yeah, very interesting. So, and final question before we go on a break. So it's for everybody. So again, in the foundation when we build nodes and stuff, we always thought about, okay, this node should be run on just a regular laptop so anybody can run it. There is this Ethereum on Raspberry Pi projects, there is DApp nodes and yada, yada, yada. But for you, like moving forward, is it still a dream to achieve this level of decentralization when people actually run their own nodes? Or, yeah, what's your like vision of the future? And maybe some final thoughts.
So my thoughts on that are the Ethereum should always be, we should be striving to be able to run the nodes on any computer. Raspberry Pi, like that's a great idea, but it's definitely not feasible for the future in its current state. I think depending on the node, it's around 12 terabytes for the Ethereum chain, and that's only going to grow more and more to the future. So I think there's going to be more of a push towards light nodes to ensure that happens. And as we move to the forward, we'll have to look at other long-term data availability solutions like Covalent to ensure that this vision of decentralization can remain.
Love the questions, thank you very much. I need to get a shout out to Paul from DevNode. We're young, we're small, we have 350 nodes live. You can go to network.hoppernet.org. Yeah, that needed to be, sorry. There is 350 people, single individual people who are running a Hopper node. And I think that's the beauty about it. That doesn't make us better or worse, it's just, you know, it's small and it's working. Why I'm telling this story is we always try to do it from day one. That's the reason why we partnered up with DAppNode. That's the reason why they have a co-branded device. It says, you know, laser engraved Hopper, it's all cool. You got some GNO in the very beginning. So I think it's fairly good value for money. Why am I mentioning DAppNode? Because it's not only a Hopper node and only available for Hopper. You're able to do many other beautiful things with this DAppNode. I'd love to see DAppNode grow a lot more because it's the beginning of it. Not even a developer starts by putting a rack in your, you know, basement. That's not cool because it's too loud, it's too noisy, it's too and so on and so on. Was it always easy? Hell fucking no. I think we should have started like clever people did in this round. Did we learn a lot? Yeah, but I can only tell everybody in this room, go to DAppNode, have a look what they have, buy your own little device, and you'll get for your projects lovely stories like, I think a year ago there was a fisher boat in Vietnam running this Hopper node while sailing. We know it's stupid, but it was cute and it was nice. And the first time a user tells you from the community, hey, we finally managed to get it up on a Raspberry Pi, you're like, oh my God, it's a hell of a shitload to do, but it's awesome. Just do it.
Yeah, from my perspective, we already discussed it like internally. That is, basically, there's no restrictions that you can't or you can have your own node. And we spoke a lot about possibilities inside of the RPC network. And as I mentioned before, sometimes users need just an access to data. And it does not matter like how fast it is or like how maybe any other metrics could be not so like relevant for him, but price will be the most important thing. So why not? Why we can provide this kind of opportunity to these guys. And from my perspective, it's more about preparing everything to just be sure that quality not getting worse with this. But if final users pretty happy with that and we can help with that, I am like all time for that.
Yeah, so I think, I mean, we've done some initiatives towards this. I mean, shout out to the Aragon team. They've really made running an archive node in particular so much easier. I mean, I think it's 2.7 terabytes right now for Ethereum. Full archive syncs very quickly, et cetera, et cetera. That is certainly within the reach of most people in wealthy countries, at least. But I think that's the big challenge. It's simply, for either technical or financial reasons, very, very difficult for people to run individual nodes. And I don't think we have enough of them. I wish there were more. I hope the technology goes towards, and I know with Aragon version 3, certainly in terms of the total disk footprint is definitely going down. But the CPU and RAM requirements are still very high. So, I mean, it's out of reach for a large percentage of the population of the world to do that. However, that is where we need to, I believe, that's where we need to go towards. And we have services like chainsnap.io where you can pay relatively small amount of money to download what we use ourselves internally for snapshotting the entire blockchain data. And that's certainly a data availability option as well in terms of this. I don't think we personally will ever go away from having archive nodes. What is it, 4.4s? The proposal, I think I was talking to the Aragon team afterwards, and they're also not going away from ever doing archive nodes. So I think, you know, not to mention Aragon again, but they are a really great team. I work closely with them, and I think I think they're doing a great job towards data availability.
I think technically Aragon 3 kind of has 4.4.4.4 because what it tells that historical data should be off-chain, and technically it's going to be in snapshots off-chain.
Yeah.
If we go in technicalities, but
so yeah, it's fully immutable data.
Yeah.
Yeah.
Okay, but
What
thank
about
you very much. Oh yeah, sorry.
What about you?
Yeah, I think like it's very important if we look into the future that the kind of Ethereum or Gnosis chain or something becomes really like more like a settlement and a trust layer for L2s, especially where we are kind of moving towards. Then the more distributed it is, the better. Like because it's kind of protected by this decentralization of consensus. More technical details in my talk, by the way, in the next section. But yeah, it also allows things like L2s not to care about that much. So they might require like crazy servers with like terabytes of RAM or something to run them. But if it's set also on Ethereum, that's people just run out of the garage. It's much safer for everybody. So I think it should continue. That's let's say at least this kind of a root chain level nodes should be able, like people should be able to run, and the more people are able to run, the better. And yeah, I think that's about it. Thanks very much for everybody who joined the panel. Please just do a round of applause, and yeah, we can do on a break.
Thank you, Igor.
Yeah. Okay, good. Thanks for participating in block 1. We're going to have the second block starting at 4:20 p.m. Until that, we're going to have a short break, coffee break. And after the second block, we're going to have a meal break. So if you stay until the second block and the third block, you're going to have some food. So let's come back to the stage at 4:20.
Ses. Ses deneme. Ses deneme. Ses prova. Ses prova 1-2. Ses deneme.
1, 2. Yeah. Hey guys. So we starting in 2 minutes. Please come back to the stage and call your friends here. I'm gonna go to the foyer and make the same announcement. And if Costanza is here, yeah, she's not here. Yeah. What? Okay.
But maybe we should make an announcement outside there. Yeah.
Volume, there we go. Hello. We are staying on schedule despite people lingering in the coffee break. So we want to welcome Costanza to the stage to talk about censorship. And I think we will pull more people in over time. So I suggest you start slowly and ramp it up because we're slowly pulling people in. We'll try one more time, but I think you can start.
Hello. Okay. So hi everyone. My name is Costanza, and first of all, a question: can you hear me? I don't have much voice, so I can shout. I can be energetic, like I normally try to be. So please, if you can hear me, just wave, and I'll try to make an effort. So I work for the, wait, how does it work? Because, yeah. I work for this Worm Foundation, and today we're going to be talking about censorship. What it is, why we care about it, and what we can do. I want to make sure that everyone here is comfortable. So we're going to talk about genocide and extreme violence, referring to episodes that are in the past, but not too long of a past to be forgotten. So if you don't feel comfortable for whatever reason, please feel free to leave the room and come to me later. Also, disclaimer, I do not represent any organizations that I am or I was affiliated with. I'm here on a personal capacity, and I'm not a lawyer. This talk is not legal advice. I'm not telling you what you should do or you should not do to be legally safe. So, without further ado, this is what we're going to be talking about. So, the interplay between censorship and freedom of speech. We're going to look at the legal elements, and we will see that law is a means to an end. Then we will see what's the final goal of censorship. So we're going to look at governments, and then we're going to look at the institutions. So what's going to force censorship? How does it happen? And this is by institutions. So finally, we're going to see the spectrum between censorship and freedom of speech, and what we can do to protect ourselves and to avoid it. So I guess here we all agree that censorship is bad and people should be free to express themselves. So let me ask you a question. Where would you draw the line for freedom of speech? Some of the hardcore believers, and I know some of you here, will say never. And are you okay with knowingly insult someone? I am. My father was a cartoonist, and he did some pretty naughty stuff. So legally, I would say yes, but freedom of speech also goes hand in hand with respecting one another, and what we say, be excellent to each other. So here comes the twist. Freedom of speech is a right, but it is also a responsibility. You can literally kill people if you fuel violence and stir up hatred. And the higher the number of people listening to you, the heavier your responsibility towards creating a community that fosters constructive criticism. And this is because fueling hatred, fake news, justifying violence is not freedom of speech. So what is freedom of speech? According to the Universal Declarations of Human Rights, and I know the UN is a very Western-centric institution, and I'm not saying that, but I like this article. Everyone has the right to freedom of opinion and expression. This right includes freedom to hold opinions without interference and to seek, receive, and impart information and ideas through any media and regardless of frontiers. And this is very cute, isn't it? Too bad that this very article and this idea of freedom of speech led to some of the darkest moments in human history. What if you could back in time and stop Hitler's propaganda? What if you could stop the radio when the radio was promoting the genocide in Rwanda? Because those are the real questions, and those are the questions, those are the reasons that governments are using to have an infrastructure in place that they can stop whenever they want, that they can just shut down if they feel like. And those are the questions. So, on the other hand, if we start limiting freedom of speech today because, Tornado Cash is money laundering for terrorism, and tomorrow OnlyFans because pornography is bad, and then Instagram and Twitter because they're spreading propaganda. How long before we end up in a dystopian Handmaid's Tale reality? Not long. And if you think about it, this is nothing new. US, Iran, the Roman Empire, France, ancient China, Venezuela. What do they have in common? Yeah, you got it right, censorship. This is because it is nothing new. It is nothing that was invented 10 years ago. And it is like the most common thing in the world, unfortunately. So a comprehensive analysis of censorship overall will take too long and would be also out of scope here. So here we're going to focus on censorship of crypto projects. So in particular, the power dynamics behind it. So in other words, we're going to be looking at the act that prevents people from using software. And we will try to answer the question, why does it happen? How does it happen? And I'm not talking about extreme cases like preventing a genocide. I'm talking about preventing people from using a software because their IP address is in the wrong country, or because they use a VPN, which happens quite often. So there are three elements at play here. There is the law, there are governments, and institutions. And in the end, there are affected projects and people. So law. Some anthropologists see law as a means to an end. And I like this approach because it's very practical and it goes to the root of the problem. So it follows that human activities are determined by specific problems. And this guy Malinowski is the father of modern anthropology. And it says that in looking for law and legal forces, we should try to discover and analyze all the rules conceived and act upon as binding obligations. So that means that violating the rules means the end of the institution. The final end of the law is the preservation of society. And laws should be obeyed willingly and spontaneously. So what does it mean? What happens? What are the institutions that we need to preserve? What is the society that we should preserve from what? Before moving on, another element that is very important. Technology goes way faster than the law. So what we're building today, maybe like not really yet regulated because all of you are going way faster than people back in the government. So that means that crypto projects exist in a gray area, which is a future because everything not illegal is permission, unless you're in Italy. Then in that case, it's another story. And one other element, law doesn't work like a smart contract. It is not like you kill someone, you go to jail. It doesn't work like that. Not common law, not civil law. It is way more nuanced and complicated and complex, and there are way more elements at play. What are those elements? So, the governments, why do they censor? And this is what society will look like if censorship was at place. They say that they want to protect us from money laundering, from criminals, terrorism, legal sanctions against enemy countries because this is super bad and they need to protect us, preventing illegal activities, fighting fake news. So we're gonna play a game now. We're gonna get out of this amazing bubble here today, and we're gonna step in the shoes of a fictional government official. Our name is Seymour Skinner. The year is 2024, and we face every day with new challenges. The world that we train for, that we grew up in, does not longer exist. Now we have like all those things like permissionless, anonymous, no central authorities, and how can there be society without central authorities? Like all those things like Web3, cryptocurrencies, mixers, privacy pools, they're a pain in our ass. We don't understand them. And we think that they're dangerous. And this is how they see us, without realizing that this is what we are like. So what does this mean? This means that they have a lack of understanding, they have a fear of irrelevance, and what do? They just try to censor. And they do that by using institutions. This is because in a centralized world, you need corporations from infrastructures that are acting as institutions. So let's see how that works. We like to say that we don't believe in institutions, but if we are honest, today we do have institutions. In order to protect crypto projects, it is helpful to abstract and look at the actors involved in sanctioning. So, AKA the permissioned, centralized institutions that we rely upon. So Malinowski, the guy we said before, said that the work of society is done not by community as a whole or by individuals, but by small organized groups, institutions. So what are the institutions here today? Organizations like AWS, GitHub, or centralized RPC could be considered institutions today. They are structured. They are created to carry out specific functions. They have a set of rules that govern their behaviors. And before we say that laws should be obeyed willingly and spontaneously, how does it work in practice? Well, those institutions comply with the censorship law, and their actions have a snowball effect because they can decide who is going to be censored and who is not going to be censored. So let's see how it works in practice. Freedom and control is not like black and white. They're on a spectrum. And on the extreme left, we have freedom. On the extreme right, we have censorship. So let's look at how those interact with freedom of speech. We have another spectrum where on the extreme left, we have non-compliance. On the extreme right, we have over-compliance, meaning when they go above and beyond. And here, somewhere around here, we have perfect compliance. So here, in perfect compliance, we have somehow like on the censorship end of the spectrum, and it is enforced by the government. This is what governments want it to be. So someone may argue that by doing so, you can guarantee access to your platform to other people, to as many people as possible. So centralized infrastructures, they have to comply in order to be able to serve people. Spoiler, normally people in countries where the centralized players are first-class citizens, while people in other countries are dual-class citizens. They matter less. So here, and this is like really, really scary, because here we have over-compliance. We go above and beyond what the government wants. We still have dual-class citizens. And who is where is decided not by governments, it's decided by centralized players. So they can literally decide to shut it down at their will. And finally here, we have total freedom, we have no compliance, but it is a very risky spot because people might get arrested, you might have sanctions against yourself. And those are the questions and the trade-off, but those are the questions that should be up to you. So if you want to know if your project is going to be censored or not, those are the two questions that you should look. How much does Seymour Skinner feel that you threaten the system? Does he understand you? Does he understand what you're trying to do? Or he just doesn't understand and is scared? Those two things go hand in hand. And if you're relying on a centralized platform, you should also look into the risk appetite of the centralized platform you rely on. Now, this is the situation today. Personally, I'd like to be optimistic. This is because, first of all, Ethereum blocks censoring IP addresses are in decline, in a very steep decline. And we do have the tools to replace the current infrastructure. So what can you do? First of all, you should, yes, you should, not you could, decentralize the hosting infrastructure. As long as you rely on all those centralized players, and I'm not going to name names, you depend on them. And they can do whatever they want to your project. You should decentralize funding. You can look into DAOs, you can look into other places, but just make sure that also you personally, as a human being, are safe. So yeah, also go anon if you can. And this is because each one of us has a different perspective. Each one of us has a different risk appetite and a different plan. And that is totally fine, as long as the decision is yours and not someone else. Because it's your code, it's your project, it should be your risk appetite. It should be your choice where to be on the spectrum. And finally, one last piece of advice, and this is legal advice. Get yourself a shadowy supercoder. Thank you.
Great. Thank you very much. We have time for a couple questions. Any questions? Do we have a question? Yes, we've got a question. Great, 1 second here.
Thank you. Simon from Forecash Exchange. I want to come back to the major point where you mentioned a two-class society, which is the goal of government in the perfect compliance area. So I can tell you the government actually don't want a dual-class citizens. They just put a lower KYC on Western citizens than put a KYC on blacklisted countries. But infrastructure can just say we apply the highest compliance on all and treat everybody equal, and we don't make exceptions. So everybody is the same, and every compliance procedure is the same. It doesn't matter where you come from. 180 countries is the same compliance process for everybody. So the government supported, at least in Switzerland. I'm not sure about other places in the world, but there's no government which tells us we have to treat somebody from India different than somebody from Iran than somebody from the US. We can just apply the highest standard and use it for everybody. Thanks.
On this point, my analysis was from a few months ago, so maybe they changed the terms and conditions. GitHub said we might need to block content if we receive a complete request from a government official so that our users in that jurisdiction may continue to have access to GitHub to collaborate and build software. So yeah, exactly. Like, that's the thing. In some places, you can just use GitHub. You can be hands-on on GitHub. Some other places, not so much. And I personally don't understand why me from Europe, I should have more rights than someone else from another country.
Any more questions? All right. Well, listen, let's give a hand. I think appreciate the talk. Thank you so much. Great. Thank you. And now we have Bernard, Chief Scientist of Fluence Labs. Oh, no, sorry. Scratch that. We have both Bernard and Evgeny. So Evgeny, co-founder of Fluence Labs, and then Bernard, Chief Scientist of Fluence Labs as well, to come up. Thank you.
Hello, everyone. Thank you all for coming. And this is going to be like a little bit technical talk, but I will start from high level so everyone can understand me, and then Bernard going to hit with all the engineering details. Like, we are the Fluence working on a decentralized serverless platform, and you would wonder how is it related to all the RPC business, and I will tell you in a couple of minutes. So, but just initially the context for everyone. So there is a cloud computing business. It's like hundreds of billions of dollars. Like, it's basically where all the backends of the whole internet live. Like, all the most of blockchain nodes, unfortunately, live in the cloud, as we know. And there is on top of basically servers and infrastructure, there is the whole layer of cloud services that these big companies like Amazon and Google created over decades already. And one big segment of this cloud business is a serverless products. And it's sort of like the most comprehensive solutions that makes the experience of developers using it as simple as possible. So when you're using serverless, you're not thinking about limitations of particular servers, of physical hardware. So you have this elastic scalability, you have great, like you can easily build stuff and you can iterate quickly. So at Fluence, we have this vision of bringing this serverless experience in a Web3, in the decentralized world, and basically building these serverless products. But details are more interesting here. So this is just a quick mapping on some products that Amazon has. Like basically, they have this functions as a service called Lambda, and we have functions in WebAssembly. They have step functions of workflows, and for this, we have our own solution called Aqua, which I'm gonna talk about now. And they have a lot of like services that we also have analogy to them. But so quickly, again, like iteration on like Fluence is a decentralized network. So right, it's managed by DAO. It's built on top of the marketplace of different compute providers. So like anyone like who are running their validator nodes or like running, you know, like a storage provider, so Filecoin, like people basically from the ecosystem can join as a compute providers and, you know, run servers like and be capacity providers for the network. And on top of it, there is a like developer tool set that allows easiness of use for developers. And using this tool set, you can create applications. And what kind of applications it could be. So you can, like, simplest thing is like, I have a piece of code, I run it in Amazon, so now I can run it on Fluence, sure. But more interesting thing is the all kinds of distributed applications or like multi-party applications, which are, if you think of this, which are our decentralized RPC solutions, like the example of it, right? There might be other examples like where you have basically several nodes that needs to talk to each other and somehow collaborate and somehow produce together the product. Like, for example, Oracle implementations, so like a bridge implementations, or you know, like you can imagine something crazy like decentralized messaging applications, right? And like decentralized RPC is one of the things that we think that would be really, really great to build using Fluence development stack. So yeah, so roughly the network looks like this. These are Fluence nodes run by different compute providers on the network. They all can execute any kind of code. And they are plugged to different external networks or Web 2, you know, infrastructure. They can call HTTP APIs, they can call like cloud service, traditional cloud service, but they also connected to like blockchains or like IPFS, like any kind of Web 3 infrastructure. So basically, then they organized to what we call subnets. It's basically groups of nodes that like group together based on certain logic, certain programmable logic. The basic logic is that basically the replication factor. Let's say you deploying the simplest piece of code to Fluence network. It means that you deploying simplest piece of code to several nodes, and your piece of code is replicated. So if one node goes down and doesn't respond, like the other node can basically execute your function. So it's sort of like the simplest use case of this deploying on subnets is a failover, so you have fault tolerance. But there could be much more different logic built in there. And this logic is basically can be expressed in a program. So you, to express this distributed workflow logic, we have this whole language and a distributed protocol that basically allows you to run distributed workflows without a centralized coordination place. Like if in Amazon, for example, you have these step functions that allow you to call this function, then that function, then that function, right? This step function, the language you're using to describe the workflow is they have JSON and they have a visual like editor where you can drag blocks. Here you have the whole programming language, which gives you much more power and much more flexibility of describing these network algorithms or workflows. And some examples of it, yeah, so like Aqua basically powers these subnets and powers the network. It's like lives everywhere between the nodes. So it's kind of like how requests being served by the network. Yeah, so basically you can express a lot of distributed algorithms as AquaScript. Like you can have consensus if you want. Like you can program consensus in Aqua and you can put it to your subnet if you need consensus. If you don't need consensus, maybe you need quorum. You can have quorum algorithm. Maybe you want to load balance between different nodes, or like have an algorithm that that optimizes latency between globally distributed nodes, so your RPC response is faster, right? So you can have the load balancing algorithm in Aqua. Like also replication, or like we have also examples on MPC when you have this threshold signature signing scheme that involves many parties and they collaborate on creating signature together. The cool thing about this thing is Aqua has verifiability built in. So whenever Aqua code is being executed, every node, like if you have like an algorithm, like let's say from this example, it's some kind of map reduce, right? So I ask several nodes to give me price, getting from somewhere, let's say from external source, and then I'm calculating average at some other node and give it to the user. So this is like the simplest map reduce, right? So here, every node, every next node in this workflow would be able to verify that the previous part of the workflow was executed correctly, that it was correct nodes who were involved, that the inputs and outputs are like correct, and the the initial user has the right to initiate this this workflow. So basically, like as long as workflow is being executed, it's being validated by the next nodes that involved in this workflow. And also part of our kind of security and incentive model, some of these workflows are probabilistically verified on-chain. And this creates you, like if you need audit log for your system, you can basically like show like to regulator or to your users that actually, hey, we did this RPC requests that you asked us to do, or like we did this, we provide you this API response, which was combined from some other APIs, and this is the proof, like this audit log is a sort of proof that this was done as it's supposed to be done. So we haven't really, like we didn't, change things in between under the hood, right? And it's all content addressable, it's all like compatible with IPFS, so it's very, very useful. And the last thing is, like, there's a payment model built in to the network, so, but basically, like, if you're using this, you can either use nodes that being run by some compute providers on the network, you can run your own nodes, for example, and then there is a way how you pay it. So currently, payments for the execution are in stablecoins, in USDC. We want to enable it for any ERC20. So it would basically means that if you are using Fluence to create your own like subnets to run your own workloads on it, then if you want, you can either agree with compute providers on Fluence network to accept your token or some other ERC20, or you can run your own nodes as a part of Fluence network and basically this way make this payment happen in ERC20 instead of stablecoin. Yeah, and also like paying by request is coming. So now we're gonna switch to Bernard, and he's gonna talk about like particular application of this to the RPC. We have like a showcase the implementation of decentralized RPC built with Aqua and Fluence.
All right, 2 pieces. Okay. Hi, I'm Bernhard. I already pre-apologize. My respiratory system and the Istanbul air quality do not entirely see eye to eye, so I have been coughing quite a bit lately. But hopefully it's not going to be too distracting. So now that you learned sort of everything you ever wanted to know about Fluence, let's put this to work and let's start out programming decentralized RPC. And we had an entire earlier session on this, but fundamentally, as a dApp developer or in the dApp space, it's almost prohibitively expensive to run high availability clusters of EVM nodes, particularly on the Ethereum side. It's just not practical, and as a result, we have RPC as a service, which is fast, which is cheap, which is great, it produces or provides great APIs, but we have this problem of single point of failure, data integrity, and privacy concerns. Many in this room are working exactly on solving these problems, so welcome and thank you. And we're going to give you our take on how the Fluence stack can be used by you, actually, to improve your decentralized RPC solutions. Nope. Okay. So, Evgeny pointed out we have different building blocks in Fluence. Marine, it's a WebAssembly runtime. This is where the WebAssembly containers come in. We have Aqua, which is your programming language. It also has a compiler and a few other nice things. And now we're getting into the FRPC thing. So we have to add a little bit to the solution in order to make it work and make it work in a decentralized manner. If you look over there, we have a DApp, and that DApp is actually self-contained. So when you implement with Aqua and Marine, you do not have to touch your DApp. You take that URL, your Web3 library you use basically pushes out, and that's what you consume in this FRPC. We call it a substrate because, as I said, it's not a product, it's an example on how to use Fluence. And the first thing you want to have a gateway, probably self-hosted, and that gateway is your HTTP to peer-to-peer bridge. Because as Evgeny pointed out, the Fluence network is a peer-to-peer network. And when you deploy your services, we'll get to that, which are actually Marine connectors at the bottom, you deploy them into a peer-to-peer environment. And you control where you deploy your services to, these connectors to. So you have a lot of optionality from literally from green data centers to geo selection, which becomes important when we get into some of the other things like privacy. Then from the gateway, you fire off this Aqua script. Like I said, it could be it could have multiple algorithms, including a quorum, could have a failover, could have load balancing, and getting parameterized either through configuration or actually the JSON RPC request itself. So based on value of a particular method or by the method alone, you can start selecting which kind of distributed algorithms you want to put to work in order to optimize your process, your transactions, and your cost. Once you have this algorithm working, this Aqua working for you in this workflow, you basically initiate the endpoint call through your WebAssembly service, which is the Marine connector there. And that's actually the reverse of the gateway. This is an HTTP connector from the peer-to-peer network out to RPC endpoints. And in our suggested solution, I mean, you can use whatever RPC endpoints you want, but hosted RPC endpoints, I think, actually are really efficient. And if you have many different ones, you can really de-risk very, very significantly and very elegantly and very cheaply. So, in many respects, in particular around this RPC, the Marine connector is basically your HTTP request from the peer-to-peer network back out to the RPC endpoint. And maybe you can see it, I hope you can see it, it's here. And there's a little bit more to it, but fundamentally, even on the WebAssembly side, it's a very low-code solution that is very similar to your traditional request W in JavaScript or Rust or Python. If you want to write a particular algorithm, like a quorum algorithm, this basically is it. And the quorum algorithm is interesting because it actually helps you or can help you decentralize on two levels. It can help you decentralize on a single point of failure because you will be calling multiple RPC endpoints at the same time, and on the data integrity side. So this is an extremely powerful approach on how to handle or how to decentralize RPC very, very easily. We also have a very smaller here. It's basically a round robin algorithm implemented in Aqua. And if you look at the number of lines, I mean, those are very low code solutions that actually pack a punch because that manage all the entire peer-to-peer topology within Fluence. So it's super powerful. Anyway, so if you have a round robin, for example, we could do it randomized, but we also can cycling. So if we have 3 peers, A, B, C, we can keep cycling through them. That is actually, on some method calls, probably preferable over parallelizing, where data integrity may not be that much of an issue. And you can retain state outside of the DApp, which is actually super, super cool, because you can manage that state not just in, for example, cycling through your RPC endpoints. You can actually start tracking which of the RPC endpoints if you do a quorum, for example, is performing as a constant outlier, and over time make longitudinal decisions where you start removing non-performing RPC endpoints and replace them with other ones. So this is sort of a decentralized high availability design based on that quorum algorithm. And again, we have our DApp, we have our method request going into the gateway, we execute that script. And now in Aqua, in this particular quorum algorithm, we decide to parallelize over n, k, whatever you want to call, 3 from a slide perspective, RPC endpoints. And if you're really, really paranoid about your transaction, you can actually go one step further and have every connector call every endpoint. I didn't put it on the slide because it gets very convoluted very, very quickly. And then, of course, you get your responses back, and then in Aqua, you resolve those responses against your quorum algorithm. So if you have unanimous response, obviously you have no problem. If you have a partial response overlaps, you can now start looking at what's my quorum threshold, 2 out of 3, for example. You can add initial or alternative requirements as well, like we have here, for example. We want a minimum result. If I make 3 calls, I want to have at least gotten 2 back. And those are all like very easily programmed into Aqua and then executed. And so now you say, hey, we wanted to eliminate single point of failure, so you bring an entire network to play here. How are you not going to be the single point of failure? And this is where the entire idea of the subnetworks plays a very big role, as Evgeny pointed out earlier. And we can resolve subnetworks which rely on you as a developer or as a decentralized RPC provider, where you say, okay, I'm managing 10 distinct RPC endpoints, hosted RPC endpoints, for example, and I'm deploying 30 of my marine connectors across many different peers and many different providers. That gives you a very, very large subnetwork, which you can very easily, like in a very low-code manner, manage, and that gives you the failover at the network level. So now you have failover at the network level, and you have failover at the application level. And this is how we tackle, or this is how we think, you should tackle or can tackle single point of failures in RPC workflows with Fluence. On the privacy concern issue, there are also multiple ways where the peer-to-peer network at least helps you obfuscate your IP address. And there's things you can do because it was brought up earlier in terms of how to rewrite your packets, for example, when your headers, when you do your marine connector, if that's of concern. And if you have just your local gateway, your DAP IP goes into the peer, and then of course from the peer, the PRD goes to the RPC endpoint. So here we're really trying to work to preserve as much privacy, if you will, from the RPC endpoint, not the network itself. Within the network itself, we have very, very strong encryption, end-to-end encryption on the transport layer, and we also have on the Aqua layer encryption, which we don't have time to get into, but if you're interested in adopting Fluence, for example, to build out your decentralized RPC solution, come talk to us for sure. So what does this now actually look like? So you write this Aqua script, right? You have your gateway, and I'm here using our CLI, so it's not literally a gateway, but the CLI, to make a request. That request is quite verbose. It wouldn't be that verbose if you do it in the gateway or programmatically. But I also want it to be as explanatory as possible. And this gives you your method we want to call. This is your relay. So basically what, as I said, you connect to the peer-to-peer network. The way you connect to the peer-to-peer network is through a relay. Relay is a publicly available and accessible node. And then you start pumping through your various RPC URLs, which of course you can do through a configuration file. You wouldn't have to do this manually at all. And in a quorum type environment, and this is where we had 3 RPCs, and we did, every connector did 3 calls. You now get from every connector, you get your block heights back, for example. And in this particular example, yes, they all line up, so this was a good day. Sometimes this is also like a really great feature and super important. if you get a quorum result back, you don't necessarily, depending on the method you're using and or the parameters with the method, you can programmatically decide within Aqua that you actually don't want to accept the quorum result, but you want to repoll. Again, this logic is outside of the DApp. Your DApp is not affected by it at all, which gives you a really, really high degree of flexibility to build generalized solutions. So, that was sort of the quick intro into how to program decentralized RPC solutions with Fluence. We went through all the major points where we want privacy. The additional aspect, and Evgeny mentioned it, there's a verifiability aspect to it. And if that's something of concern when you build solutions, you basically get this for free. And that's actually, it could be very, very powerful depending on who your customers are when you do this. Other than that, stay in touch, reach out. We're here, obviously, for the rest of the day and for the rest of the week. Twitter, well, we get them all. Well, Discord. And
thank you, Bernard and Evgeny. And we've got a couple unless anyone here, any questions? Or is everybody ready to build their RPC solution on Fluence right now? If you're ready to build it right now on Fluence, then we need no questions. If that's not the case, anyone's not 100% ready, then let's have some, what are the questions? Why not? Any questions? I guess everybody is ready to use Fluence as soon as they leave this room. That's the message I'm picking up. Oh, we got a question. All right, one person isn't ready yet.
So one aspect it's not very clear to me is the gateway part. So gateway part, usually in a gateway there's an URL, public URL with a domain. So how do you handle that? How do you handle the decentralizing this part?
Okay, so there are different approaches to it. The easiest, in my opinion, is to have the gateway self-hosted with your DApp. So you control the gateway. So I'm not a big proponent of now going out to Amazon and start hosting a gateway. This is like the anti-pattern, right? Over time, we'll probably provide a decentralized gateway as part of the Fluence solution, but right now that's a little bit further out. So right now, I think you would take in this by putting in the local host IP. You want to run it with your DApp, and I think both from a control perspective, decentralization perspective, and availability perspective, it should work extremely well, because if your infrastructure for your DApp isn't working, then obviously your gateway isn't working, but it doesn't matter, right? So you really pair it up. And the gateway itself, I mean, the way we implement it is just a itty-bitty little HTTP server. Literally, it just takes that output from the DApp's Web3 library and then flings off that Aqua script parameterized with that JSON RPC data onto a relay. So it's extremely lightweight. There's not much going on in that particular sense. It's just literally the bridge between HTTP and peer-to-peer. And you could build it into your DApp, but one of the advantages, there's a lot of things you could do. So if you want to build on, we have a lot of ideas, and we've tried a lot of things, happy to share. But one of the things I like about this particular pattern is that if you have multiple DApps, you can reuse that entire script process, the entire Aqua process, your marine connectors across multiple ones, and really get pretty good benefits on performance and, of course, code reuse.
Great. Any other questions? Going once. Okay. So thank you again, Bernard and Evgeny. We're now looking for Andrew from Consensus. There we go. Come on down, Andrew.
Yeah, just while we're preparing, we're going to have food, finally, after this block, so like between block 2 and block 3. So for those who are hungry, we're going to have it. So, yeah, Andrew.
Correct. Thank you. I don't see the
Sounds good. Cool. Thank you guys. Sorry, one sec. Just a quick technical change up here. Cool. So, hey everyone. Good evening. Thanks for being here so late on a Wednesday. So I just want to kick off as well with a big thank you to the Fluence team for organizing this awesome event and bringing together so many bright people on this like really exciting and important topic of decentralization at the RPC layer. So my name is Andrew Breslin. I work on the product strategy team within Consensus, where I focus primarily on our infrastructure-related products and initiatives, so things like staking, bridging, and most recently, the Decentralized Infrastructure Network, also known as DIN, and that's kind of where I'll be focusing my talk for today. So we as Consensus kind of first announced our intention to help decentralize the RPC layer at ETH Berlin last year. At that time, we spoke about Infura's history and the longstanding commitment that Infura has made to provide the Web3 developer community with access to production-ready and reliable Web3 infrastructure. Since 2016, the Infura team has been working hard to deliver on this commitment, and so far we've been able to empower over 400,000 developers to build and grow the Web3 ecosystem, while providing a service that consistently achieves 99.99% uptime. But doing this has meant running an increasingly complex tech stack, developing protocol-specific knowledge and insight, and making ongoing investment in both our operations and our infrastructure to ensure that we're able to provide this kind of high-quality service. In the past, this combination of complexity and cost has presented itself as somewhat of a centralization vector in our industry. And that's because it kind of limited who could provide a service like Infura's at the scale that Infura intends to serve. However, as you guys all know, and as is clear to me as I think about like all the teams that I just met today, there's now this kind of flourishing ecosystem of Web3 infrastructure providers that has emerged over the past few years. And it's really this ecosystem and all of you that have made it possible for Infura to kind of take this natural and inevitable next step towards progressive decentralization. If we truly want to onboard the next billion users and developers in Web3, we know there's not much that we can do about that ourselves. And so last year we announced our plans to build DIN, the Decentralized Infrastructure Network. So this is a network of infrastructure providers who intend to work together to provide unparalleled API access to blockchain infrastructure. So, oops, sorry, I think I'm ahead here. Awesome. Okay, sorry about that. So since announcing DIN last year, we've been fortunate that many of you in this room reached out to us to offer your help as we started down this path towards decentralization. So some of you, like us, were very eager to get started, and others had actually already begun working on their own decentralized RPC initiatives as well. And you all reached out to us too to share kind of your experiences and the insights that you've gained from your own decentralization journeys. And for that, we are truly incredibly grateful. Today, I'm here to do three things primarily. So the first one is to recognize the teams that have partnered with us over the past 14 months. The second is to talk about what our teams have been able to accomplish together so far. And then third, I want to talk a bit about DIN's roadmap through March of next year. So as we mentioned, the first thing that we want to do is to take this opportunity to really recognize the partners that have been active participants in the initial group of providers and protocols who've helped us start building out the decentralized infrastructure network. So bear with me because I have a lot of teams to thank here, and also for the DIN partners who are in the room, feel free to like give a wave or stand up or whatever you want to do when I mention your team's name. So without further ado, I am honored and thrilled to share with you all the initial set of DIN partners. So in the dotted box here, you can see the providers who I think are in the room today. And so we've got Chainstack, Covalent, Everstack, Ellipfra, Gateway.fm, Grove, Laconic Network, Link River, Mantle Network, and Matrix to Link. Thank you. So there's also a whole bunch of providers here outside of the box. That just means I don't think they have a representative here, but they might. And if they do, let me know. But they are 0x Fury, Block, Linkpool, Lucent, Microsoft, Pocket Network, Rivet.cloud, and Tencent Cloud. So yeah, thank you all to these amazing DIN partners. Awesome. Yeah, so each one of these 18 groups and teams have dedicated a ton of time to getting us to the point where we are today. So really, it should be all of them presenting, not me up here, but hey, that's what you get. So on that note, I'd love to share a bit more about what our teams have been working on together. So after ETH Berlin, we began talking with those partners that I just mentioned, and we met with a lot of them in person at this year's ETH Denver event. What we aligned on with those partners was that there are really three important prerequisites that DIN has to solve for if it's going to be successful and work in the way that we intend. And so those three things are primarily consistency, economics, and quality of service. So first is consistency. The network has to solve for having sufficient consistency in terms of the requests it receives, but more importantly, the responses that it provides. The upside of taking this decentralized approach is that in this system, the system's availability increases both in terms of like the networks that it supports and the uptime that we can achieve as we add additional partners. But those who've worked in distributed systems and are familiar with CAP theorem know that the consistency also has to be good enough so that users aren't plagued by inconsistent responses. The second big challenge for DIN is economics. So put simply, the system's economics have to work for every system participant. Regardless of whether there's a token involved or not, the mechanism design and the implementation of those mechanisms needs to make sense. So if a provider offers a service, it has to be something they can sustainably support. In other words, users have to be willing to pay for it, and they have to be willing to pay enough so that the provider can generate revenue and keep the lights on and keep that service being offered. And then lastly, we need to ensure quality of service. So DIN will only be as good as the minimum standard that DIN partners are required to uphold. And so at this stage, there has to be kind of acceptance criteria and tests performed to ensure that the members of the network are able to meet the quality of service that we intend to provide with DIN. So we left ETH Denver knowing that we needed to better understand and focus on these challenges. And so we began to look at some Infura data that we had internally to see if we could better understand how to address these. So to move forward with a federated, oh, sorry, I think I skipped some content here. Perfect, yeah, so after taking a look at Infura's data, we came to a pretty clear conclusion that we first need to establish and run a federated version of this decentralized infrastructure network. The federated version of DIN will allow us to iteratively and collaboratively explore and work on these three challenges with our partners in a production environment before we introduce like further levels of true decentralization. The data that we intend to gather from DIN's federated phase should ultimately provide guidance and inform how we move forward and build a more resilient network. All right, so to move forward with a federated version of DIN, we spent some time over the summer establishing a V0.1 of the DIN partner acceptance criteria. We worked with the partners that you just heard about to test their endpoints as well as our own Infura endpoints across 5 initial networks. So in Ethereum mainnet, Arbitrum, Avalanche, Optimism, and Polygon. We had a lot of learnings during this process, and in September of this year, held another in-person meetup in New York City to debrief and talk through what our next steps should be. Coming out of that meeting, we created these 3 working groups to address the 3 biggest challenges that DIN faced. And so those working groups focus on routing and inter-partner consistency as number 1. The second working group focuses on the economics of DIN. And then the third working group is focused on acceptance criteria and quality of service. Perfect. So these sessions in New York were ultimately really productive for us, and they allowed the DIN partners to attend it both in person and remotely to kind of self-organize into these groups. And since then, each of these groups has made some really impressive progress. So first, we've been collaboratively building a routing protocol that seeks to create a strong consistency of responses for any user of the network. Second, we've started to establish a service discovery model and figure out how the economics of that offering should work. And then third, we've iterated on the DIN partner acceptance criteria and created a new set of stress tests and health checks that all partners, both current and onboarding, will have access to. So you might be thinking, like, what does all this work get us in a practical sense? Well, let me focus your attention on our roadmap and kind of where we are today. So right now, we're in the middle of Q4 of this year, and thanks to the efforts of our DIN partners and each of those working groups, we're getting very, very close to enabling RPC failover on Ethereum and Polygon via DIN. And when we say failover, what we mean is we'll be able to automatically and seamlessly reroute traffic from Infura to any number of our DIN partners. So in the coming weeks, current Infura users will be able to opt into this failover protection, which gives them access to request rerouting through DIN in the case of an outage on Infura. In this way, we'll have taken the first tangible step towards providing greater protection for our users and reducing the centralizing gravity that historically we've had in the space. So next quarter, we intend to expand this failover protection beyond Ethereum and Polygon to Arbitrum, Optimism, and Avalanche. Taking the approach of federated failover first gives us the ability to move in the direction of decentralization and address any issues that arise regarding consistency, economics, or quality of service. And at the moment, we recognize our approach is fairly methodical and it's intentionally cautious. But we know that we also have to become more ambitious in terms of adding new network support and new endpoints, both to Infura via DIN, but also allowing our partners to kind of expand their capabilities in the same way. So in Q1 of next year, we plan to add 3 new networks to Infura via DIN partners. So one of these networks we know will be Mantle Network, who is the first protocol to have sought out and joined DIN. They're working collaboratively with Infura and other DIN partners to create a method that will allow DIN to offer support for their network. And we're honestly really thankful for their collaboration and for the trust that they've placed in this network in this early stage of the network's development. We also want to say that we encourage all other L2s, L1s to reach out to us as well. We'd love to figure out how we can support you. So the next big update that you'll hear from us will happen at ETH Denver next year. We plan to meet with the DIN partners there again, and we think that our efforts over this quarter and the following quarter should give us the data that we need to prioritize and decide what DIN's next step should be. Among other things, we're thinking about how to provide service delivery via a smart contract, how to enable cross-provider payment streaming, and a whole host of other ideas that have been thrown around. We'd also love to hear some of your ideas, if you have them, for how we can improve DIN's offering. So doing this and adding any new functionality to DIN is going to require building and testing these solutions collaboratively with all of the DIN partners. So over the rest of this quarter, we'll be identifying what those issues are that we want to tackle in our time together at ETH Denver. We see this as an important opportunity for us to keep pushing forward on our federated model and to begin experimenting with even more decentralization. Cool, so as I close up my time here, I just want to recognize that although we did mention just 18 DIN partners, we're speaking to and working with many others who are currently onboarding to the network. And we're really excited to have each and every one of you join. We really do think that DIN can become this kind of important infrastructure layer or a network where collaboration is possible amongst every RPC provider in our space. We started working on this problem from our existing position as a more centralized service provider, working to progressively decentralize. But many of you in the room have approached this same problem from kind of the opposite side, delivering RPC services from a much more decentralized place and then continuing to push further towards decentralization. So I think it makes sense, and I think we have a lot to learn from each other in terms of how we can work towards achieving decentralization at the RPC layer. And I really do encourage all of you to come talk to me or come talk to any of the DIN partners in the room that we announced here today. So yeah, that's it for me. Thank you.
Thank you, Andrew. Do we have any questions? Any questions? Yes. All right, hold on.
Hello, my name is Constantine from grpc.org. So for me, it's one of the most interesting parts here. It's what do you plan regarding to fallbacks? It's just you will keep all of your nodes, like all of Infura nodes, and if something happened, you will send the request to the providers connected to DIN, or you plan to, any kind of, stop all of your Infura nodes on the backend and start to contribute only for development software above all of this network to help guys to solve the request by their own. It's one of the questions. And another one, is it part of your strategy to also send their request from MetaMask, or MetaMask will be still on centralized Infura?
Gotcha. Yeah, great question. So our thinking around how Infura and kind of every other DIN partner coexists within DIN is that they will, like I said, coexist. So we're not going to shut down any of Infura's current operations. Really how we see DIN is kind of like a complement to the existing providers that exist in the space. So Infura being one of them. And right now, Infura is kind of playing a coordination role for DIN, but that's only really the intent for this federated phase. As we adopt more layers of decentralization and kind of dive deeper into that space, we really want to kind of relinquish control and become just another provider in the DIN network. So yeah, we intend to continue operating all of our Infura nodes as we do today and have DIN as kind of like an extension of our current capabilities, including failover as kind of the first feature that we intend to ship.
They'll be equal, right?
Yes, yeah, exactly. And sorry, what was your second question?
And the second part, it's about MetaMask, because MetaMask, it's really a huge part of the Infura business, so it's really interesting.
Yeah, exactly. Yeah, it's like a lot of our traffic comes from MetaMask, and I think we'll treat traffic the same kind of regardless of where it originates. So I think originally it'll only be kind of failover in the event of an Infura outage that's rerouted through DIN. But as the system gets more mature and as we onboard partners that enable us to provide support on new networks or provide new endpoints, I think more and more of that traffic will eventually flow through DIN and through other partners.
Great. Any more questions? Thank you. All right, I want to remind everybody to use the QR code that's about to come up, where we have a quota of questions that must be asked anonymously, and that quota has not been fulfilled yet. So thank you again, Andrew, for your talk. Thank you. Appreciate it. But so use that QR code. We need more questions. You're not making the quota. So we've got to get everybody working on your questions. So now we'd like to welcome Igor, who was last up here moderating the first panel we did. So now, Igor, the stage is all yours to yourself. So welcome, and good luck.
Hi everyone. I'm Igor, and I'm gonna talk L2s today. We spoke a lot about different ways of decentralizing. It was all about the nodes, and I want to go a little bit technical and philosophical here, and basically talk about ZK rollups. And first, a little bit about me. In my pre-blockchain life, I used to run mobile browsers and then fintech at the browser company called HOPR. Then for a while I've been a core dev in Ethereum. I was doing the Aragon client, and now I'm the CTO and co-founder of Gateway. And since we are not as famous yet as Infura, for instance, I'll have a couple of words about us. So we do quite a lot of things. We have RPC. We are kind of we support about 10 networks, but We are kind of the provider for Gnosis, Luxo, and Stellar, where we actually work with the foundations to provide the whole necessary public infrastructure and public goods. We also do quite a lot of staking, again, partnering with the likes of Stakewise, Lido, and just vanilla. Presto is basically, right now it's essentially a rollup as a service that we're evolving towards to be like a platform as a service. And we do some core engineering efforts as well. Again, for Gnosis, I mean, there will be soon like ENS version for Gnosis, which we will provide infrastructure for. And we work on nodes for Polygon zkVM, and I mean, we just made Aragon work with Polygon zkVM, which brings the node diversity. I think the first node diversity for ZK rollups, essentially. I don't think there's any other ZK rollup that has more than one node implementation, which is, again, hope good news for everybody who runs infrastructure here. And based on that, I want to talk a little bit about, again, ZK rollups. And I have this thesis here that we're talking a lot about decentralization, but actually when you have ZK proofs and you run in ZK rollups, you kind of have quite a bit less pressure of decentralizing your rollup than if you run a layer 1 or an optimistic rollup or something like that. And I'll try to defend this thesis here a little bit. And yeah, it all started basically with, again, Presto. At some point, like in the beginning of the year, we started getting more and more requests to provision layers 2. And we started with optimistic stack, and then we slowly switched to, as soon as it was ready, first just a fork of Polygon zkVM, and then right now they released a Polygon CDK, so we had to switch to that. And basically we made a very nice provisioning UI when you can do a lot, like provision your own rollup very easily. And there's a lot of customizations if you want to, and that's kind of a good part. But all these rollups are centralized, right? Which is sort of a problem here. And even like basically what we provision is that. And I would say that maybe I'll try to defend that it's not as big of a problem as people might think with all these app chains and kind of centralization of sequencers and yada yada yada. So basically, if we look at the rollup that we provision, yeah, it has its own sequencer that we run, aggregator that we run, provers, nodes. It has a bridge built in, which is a really nice property of a rollup. And then it has states, it has synchronizer, some our components in purple, and then some third-party components. So this is like the whole environment that you get with Presto. And but if you look at, let's say, Polygon zkVM main, that's how it looks like. It looks like that roughly. So it's exactly the same setup. Apart, in this case, Polygon runs the sequencer, Polygon runs the provers, Polygon and some other parties can run the nodes, which is again the case for us as well. And there's certain load balancing happening, and there are some extra tooling there as well. So it's very, very similar. So what I will say here is like equally applies to both public instances of a rollup. Again, I know the most about Polygon zkVM, so I'll go in details on that. But I'm pretty sure that other zkVMs and other ZK rollups work in a roughly similar way. So a lot of this knowledge is actually can be transferred towards other rollups as well. I will not touch optimistic rollups in depth here because I'm not an expert. And again, and what I see that more and more of them playing with any kind of ZK proofs anyway. So we'll all get to some kind of a ZK rollups, I think, in the future. So if we look at a rollup in general from a very, very high level, we essentially have a root chain in purple here, which is usually Ethereum. And the rollup itself is in green, and it consists of two things. It essentially have some software and some blockchain you run, some, I don't know, processes essentially. And it has a set of smart contracts that are deployed to L1. And together they made a rollup. And these components, they are linked together with some kind of validity proof and data availability. And all the computation and everything is basically happening in L2, which is its own blockchain, and it's usually pretty centralized, and the goal there is usually to execute our transactions as quickly as possible, and then after that, through the communication on L1, somehow settle them on the layer 1. That's how the rollup looks like. And we'll start a little bit when talking about decentralization in particular. I would say that one of the important parts of decentralization lies like in the proofs for ZK rollups. And we will look at first on the regular blockchains, right? What's happening on the regular blockchains. One important property of the regular blockchains that happens is that they kind of provide a level playing fields for everybody, right? They have certain set of rules on the blockchain, and these rules are the same for everybody who uses this blockchain, regardless of how much power you have, like, or whatever. It's basically, you can think about, there is a rule that your private key should be valid. There is a rule that you should have money for gas. There is a rule that you cannot spend more than a certain amount. And each opcode in EVM is also basically a rule. And these rules are the same for everybody. And how is it enforced? Basically, we have a lot of nodes. Everybody gets transaction. Everybody re-executes and needs to come to consensus, right? They need to come to the same result after re-executing transactions. And that's how they are enforced, because basically if your node for some reason altered some rules, then other nodes will just not get this transaction and will reject it as invalid, and things are nice. But consensus in here is a very critical part, because essentially what you want is to consensus to be as decentralized as possible, because you have only one party that controls every node. Then what you can do, you can alter these rules like however you want. You can censor transactions, you can include transactions that shouldn't work otherwise, and yada yada yada. So it's very, very important to have it purely decentralized. And what it means in reality, that your users, your like crypto degens or just normal users, they usually work with the blockchain through like two channels. One channel is obvious, is block producers. This could be validators, like miners before that. And another part is RPCs. And for consensus to really work well, to be protected, actually both of these parts needs to be quite a bit of decentralized, because if one party can capture either one of them, I argue that's both are like equally bad for the security and the kind of agency of the users. For block producers, it's pretty obvious. Like if I control all the block producers, I can arbitrarily insert any like transaction, any state transition in the blockchain. But the same as RPCs. Let's say if our block producers are all nice and decentralized, but then RPC is like super captured, then nothing stops you from basically not allowing some valid blocks to sync into your RPC. So, and since users anyway usually talk to the RPCs, and if it's the only one RPC provider, then they are at its basically mercy. So this RPC can fork the node, just alter the rules, and they will be in the right here. So it's very, very important to protect the consensus so it's distributed among like as many parties as possible. In terms of the layer 2, the schema is really similar. So layer 2 also brings kind of a level playing fields for everybody, but then these rules, instead of being enforced and re-executed by each node, they're essentially you as a you as an operator of the L2, you will have to provide a cryptographic proof for each of this rule that it wasn't broken for each state transition or each set of state transitions. And again, we use ZK proofs right now because that's the technology we have. But then this ZK proof, when it's generated, it also gets verified, but it gets verified on the layer 1. And that's a little bit of a key thing. So basically the verifier contract on the layer 1, it has knowledge of all these basically rules that every transactions have to every transaction has to satisfy all these rules. And basically this verifier on L1 is the critical path. So in this case, since the verifier is on layer 1, basically you get security of the layer 1 and the properties of the layer 1s are getting inherited there, plus the governance of this smart contract, right? And that's why if you look at the current, a lot of ZK rollups, they have an extra governance on the verifier smart contract, which you cannot arbitrarily update without at least a time lock or something. Because then what's important also that's you talk to the L2 through a bridge, right? And this bridge, it actually uses data from the verifier smart contract on the layer 1 to decide on its own operations, right? To see that if the state transition was valid or not, and to basically unlock or not unlock funds. And the bridge is also doing it on layer 1. So that means that, again, if I'm a malicious operator of a layer 2, and if I'll try to alter those rules, so my proof will, like, unless I do something with the layer 1 smart contracts, I cannot alter the set of rules because the bridge will not accept them, and then the users will always be able to, I mean, either force include their transactions or force exit the rollup, which is a very important thing. So all of these things is basically bringing like extra security and extra agency for the customers, but it's not done through decentralization like on the layer 1. It's done through actual mathematics of ZK proofs, and that the verification happens on the layer 1. That of course gives like quite a bit of requirements about how good your layer 1 should be in this case, but about it a little bit later. And now we talk about, since we talked about altering the rules, what about just completely, I don't know, removing the data, like basically kind of a denial of service attacks there for users. And that's where data availability component is very important. Because if you want to call yourself a rollup, you need to send both proof and data availability to the layer 1. And essentially, if we, again, make a comparison between the layer 1s, like Ethereum and layers 2s, initially, data availability is basically protected, again, by decentralization. The more nodes, the more companies have. Every node has state of everything, state of the world. So that means that you cannot, again, alter this state or just remove parts of the state unless you have a supermajority of the nodes to come to consensus on this state. It's a little bit, becomes a little bit more muddy with like 4444, 4844, like full dunk sharding and all these things on the roadmap when data becomes like semi-permanent. And that's why there are some interesting techniques like data availability sampling to know that enough node contains enough data about the state to actually not to be attacked on the data availability layer. On the L2s, it's again, L2s rely a lot on L1 in this as well. So basically, when you send your transaction to an L2, at first it only lives on the L2 for a while. It's usually a relatively short period, maybe like minutes or something. So it gets sent and it gets sequenced and it's batched. In terms of the KVM, some don't batch, it doesn't really matter. And then the important part happens that it's getting sent to an L1. And since it's getting sent to L1, then regardless of what happens to this L2 in general, you can always recover the state directly from L1, the state of the rollup. So it doesn't really matter if your rollup leaves or not. You can always recover the state yourself. And then, of course, like in a while, there is a proofs that's also sent there, and then it guarantees not about only the liveness of this data, but also about the security. And a special word about validiums here, or like to some extent what Vitalik told, like was it yesterday about like kind of end game for Plasma or something. So basically, if we look at validiums, validium is different from the rollup is that it lacks this DA. It doesn't send DA to L1. Why is it done? It's mostly because it's cheaper. Like data availability cost, why Optimism burns so much ETH all the time, or Arbitrum burns so much ETH, or like Polygon ZKM, ZK Sync, is mostly about data availability costs. They're pretty high. And that's why some people are basically running validiums, And again, in Validium like this, on the picture, when you just don't send anything to layer 1, it's very naive Validium, then yeah, your data is not guaranteed by anything. The operator of this Validium basically is the only custodian of this data. So if it decides to remove it, then your data is gone. Of course, there is an in-between solution, which is like Validium plus data availability committee or data availability layer, the likes of like Celestia that was recently launched, or like Near also told that they're going to participate in that, or maybe some other chains with a cheaper block space than Ethereum. And then it means that you still send proofs of things to L1, and then you send the data availability to a cheaper chain, essentially. And then it's a big question. Then you kind of rely on two chains. I don't want to even call them two parties. And both of these parties needs to be kind of good for you to have liveness and validity guarantees there. So basically, yeah, I think like what's important here is that these properties of security, these properties of agency, these properties of liveness, they don't really appear out of thin air. It just because you use the fancy cryptography doesn't mean that you have to like just ignore them, right? And they will, it will be fine. In this case, this fancy cryptography, what it allows is to borrow this security and borrow this agency from the like a root chain, from the layer below. And that means that if your layer 1 is good, if it has like a massive validator set, it's well decentralized, then you have something to borrow. But if you have the best cryptography in the world, but your base layer is controlled by a single entity, or your root chain is controlled by a single entity, then like there's nothing you have nothing to borrow there. And that means that you are still be kind of in a bad space. So I think that in generally, if we're talking about decentralization, my point of view is that decentralization is a kind of it's a means to give users security and agency to keep your network neutral. And in case you can get a lot of this without kind of a proper decentralization, if for the layers 2, if your layer 1 is really, really good, and if you're using kind of a good cryptography. And that's roughly what I wanted to talk about. Again, it's a little bit of a deep dive on my thoughts on in generally ZK rollups and ZK rollups used as app chains. And I think that's it. So about yeah, basically any updates from Gateway, we have a Twitter. And again, if you want to try Presto, then here is the URL for you. And yeah, that's about it. So if you have any questions.
Great, thank you. Yeah, any questions in the audience? Do we have questions? No questions? All right, then we are going to move briskly on to the panel. So if you are on the next panel, please come up to the stage. Who do we have for the panel? We've got Evgeny, for sure. Igor can have his third role on stage today, from moderator to presenter to panelist. All right. We can otherwise we're going to have a self-moderating panel. Or Bernard can come back up and moderate, which is also possible. And anyone else in the audience want to moderate? We can take a crowdsourced moderator as well. Open to that idea. Anyone with questions they haven't asked yet? No? Okay. So I suggest until our moderator shows up, you guys start moderating yourselves. How about that? Igor has an unfair advantage because he already moderated one, so he goes last.
So do we have any questions there, actually? Like, because if we don't, then we need to figure out questions ourselves.
I know we've been under-indexing on the questions. Yes?
Yeah, the thing is, like, by the schedule, the panel is starting in 15 minutes, so this is why probably the moderator is not here. And I don't know, we can have a break, then come back, or I think it's a bad idea. Yeah.
No, yeah, let's do it now and then.
All right, so then we should improvise as never before. And we have this QR code still for anonymous questions. You can help us right now, because I don't even, sorry. Let's check. Maybe we have some.
First question from Bernard. What time is it? That's synchronized. No. You write it down. I want to make sure I want a quorum on your responses.
All right, so no questions in the app, no moderator.
Here's how we do it. I mean, I think each one of you guys are deep in the space, so I'd like each one of you to have a question for one of the other panelists. Okay, well, Bernard, what's your question?
As you're moving forward into your decentralization efforts, how do you see customers actually coming to this new network? Are they through each of the participants, or you have a decentralized gateway, if you will? Like, how are you envisioning that part?
Yeah, exactly. I think your talk I just got the end of before around a decentralized gateway, which I think is like super relevant to what we're building. So I'll definitely want to connect with you on that. But I guess in this initial phase, like the federated version of DIN, which is kind of where we are currently, I think the intent is for customers to come through your existing provider. So we don't even want to change the endpoint that they're hitting to gain access to RPC services. But on the back end, what could be happening is their request could be routed to any of those DIN partners if it's something that the user opts into. So yeah, in this initial like federated phase, we'll have the access point be Infura for Infura customers and Everstake for Everstake customers, and et cetera.
So is it sort of the load balancing, if you will, is it right now one way, sort of from Infura to all the other partners, or is like another partner, if they have not enough capacity, can they dip into yours right now, right in the federated?
So right now, the routing protocol is still being developed, so it's definitely, it's not even one way at the moment, it's no ways. But eventually, the intent is for it to be both ways, definitely. So we want to like augment and enhance Infura's capabilities for sure for our products like MetaMask and everything else that we support. But we also want to kind of extend that capability to all of our providers as well, and have them be able to tap into Infura resources if that's something that they're interested in doing.
Great, thank you.
Cool. Yeah. Hi, everyone. My name is Sebastian, and I'm working on privacy. So coming into the space here from a perspective of what can we do to protect the users from a privacy perspective, while others are focusing on decentralization and specifically focusing on private RPC middleware that sits between your wallet and the and RPC providers. And yeah, I'm kind of interested to hear, what the various providers are thinking on the decentralization versus centralization, privacy versus data harvesting side, compliance versus non-compliance. But yeah, let's start with a quick overview.
I mean, it's a hard answer for me because I think in general privacy is good, right? So I guess like most of people thinks that having privacy is better than not having privacy, and having as much anonymity in your wallet is much better than less anonymity in your wallet. So we probably don't want other people to see how much money we have or like what transactions we are making, right? So it's kind of like fundamental principle of all Web3 that we need to try to maximize privacy. However, as we see so far that basically whenever you want to enable more privacy, you have to sacrifice something else, right? So you either sacrifice performance or scalability or user experience. And that's why basically like current public blockchains, they're public, they're not private, right? So with ZK, we now have this the chance, right? We first time have the chance to have private transactions really on these public chains. but it's not there yet, sort of. So we are moving there. So
what is the end game?
Well, I mean, it's interesting that in terms of the privacy part, like how policy, and again, I'll play a little bit with the policy here, is basically private transactions and like private transaction pools, like Tornado and others. They're not really liked by governments very much. But on the other hand, if you look at the legislation on the privacy of, let's say, bank history and stuff like this, so basically you have to have private transactions inside banks. So for me, like it's a little bit squared with, again, more like private layers too, on top of the public network that's publicly auditable, which, again, if you have decent proving system, maybe like, again, and here is finally like, again, a little bit anecdote that's, well, in the current layers 2 that's called ZK rollups, they're not really ZK at all, because ZK proofs are just basically a technology, right? It's just a validity proof of arbitrary computation there that's being sent. So ZK is just a secondary property. We just had this tech to prove a VM or to prove like a kind of a VM or something like that. So, but if we're thinking about like layers 2 for these banks, not just like a pool like a Tornado that's permissionless, but like maybe a little bit of a heresy like a KYC guard that's ZK Validium, like that's a layer 2. Then you can get basically the validity proof that don't leak the actual customer data, but at the same time by like keeping this data private by some means. So it's a bit of an interesting thing when if the whole chain is basically a little bit permissioned and private, it's fine. But if it's permissionless pool on the public blockchain, is not really.
So we heard from some of the centralized provider, a view on that, maybe from Costanza, who's working on infrastructure. You can maybe give a super brief intro on what you guys do and what your take on decentralization of infrastructure is, to take the other side.
Thank you. So my name is Costanza, and I work for the Swarm Foundation, a decentralized, censorship-resistant storage and communication network. So this is my background. The main problem is that centralized platform can be stopped. They can be transferred, so you're not in control, you don't own your data, you don't own anything. You're just a customer to them. And they can stop you whenever they want, so that's why, personally, I believe that we should aim to decentralize every single layer of the architecture stack. And that means from the repo of the code to make sure that the repo can be taken down, because as we know, sometimes that happens. To decentralizing the hardware to make sure that there is no single point of failure, up to the bottom layer to decentralize the front end. Because if like any one of those components, from the sign-on to the hardware to the where the repo is being stored, to the storage, to the computing power, to the APIs, anything, then they can stop you. And this is the problem, because as of today, we're not fully Web3. Or it is very difficult that a project is fully Web3. Web3 is actually on a spectrum, and most projects are actually Web 2.5, Web 2.7 maybe. And this is because, of course, like, first of all, the technology is still being developed. It is complicated, so sometimes it is easier to use a centralized element instead of using the decentralized one. But nonetheless, we should try to get there, and we should aim to get there.
Maybe a follow-up question. What are some technology developments we heard about? Din already some ideas. What are like maybe some ideas? Because like what Constanza says is not new, right? Like we heard about that. Maybe we can get an overview of some technological developments that are taking some of this, power of centralized platforms away and reducing the impact of it. Anybody wants to talk about some developments there?
I mean, it's again, like we focus right now. Let's say the emergence of more or less like custom layers 2 is very important one, because it brings the Web 2 customers the experience that they expect from like blockchain being like a fast database with fancy smart contracts, because a lot of the time the Web 2 developers are a little bit baffled by the fact that you send a transaction into, let's say, Ethereum, and then need to wait for it to finalize, and then they have to write like all sorts of crazy code on like TX pool analysis and stuff like this just to make a UX in their game semi-decent, because again, your customer will not understand, like if you run your mobile game or you run like on the computer, when you made like get an item, that now it takes whatever minutes for this item to actually arrive to you, when you click a button and then the transfer is not instant, or things like that. So it's an important part of bringing Web 2 like UX onto the Web 3. But I agree, there's a lot of tooling needs to basically be able to build the app from top to bottom on the Web3 components on there.
Yeah, if we're speaking about like Web3 infrastructure in general, not just blockchains, then like I'm particularly excited about Fluence, actually, working. Because like if you think of the internet right now, right? So it's HTTP, great, decentralized protocol, we love it. Well, it has some sort of flaws for sure, but it's kind of decentralized. Like we can't say it's decentralized, right? Then actually over time, we noticed a weird transition that now actually half of the internet even being served over HTTP, but being owned and served by few big corporations, like Amazon, Google, Apple, or not Apple, like Microsoft, Apple as well, then there's a big problem. So like all these backends sitting in single like data centers controlled by a huge organization, like where you have system administrator and can push the button and your service is gone, or like you can lose your business, your users, anything. They basically control, because they control the infrastructure, they control a lot of a big part of the economy, right? So that's why building the alternative infrastructure is very important, and we're building this from the cloud perspective, right?
So I think yesterday there was an interesting, bit contentious discussion on Twitter that was kicked off why are we in Istanbul right now? We should all be in DC because the US is obviously the world leader, and we should get things right there, and then all great will follow. Agree or disagree? Should we, support the US stance on decentralized technologies, or should we, stay in Istanbul?
I mean, my point is that it's good to support things, but we shouldn't only support, we should do things ourselves. Again, it's like a lot of the things it's great about the Web3 community, that you can find really cool projects from all over the globe, right? From the States, from Canada, from South America, from Europe, from Asia, like everywhere pretty much. And so I think it's also a good thing, because I think Web3 came as close as it's possible to bring kind of a common standards to developing sort of things, which are not proprietary and like open by default, and that's very important to spread the innovation around.
Yeah, I'll just add that so that's kind of another one of our goals with DIN, is to have more of like a global geographic perspective in terms of where our infrastructure lives, and also by extension the latency with which we can respond to requests in different geographies. So that's another goal of DIN, is not just kind of outsourcing all of our requests and response, but also trying to improve the service by kind of adopting these other infrastructure providers that may not just have servers located in a specific geography, but also have insight into what the regulatory climate is like there, and allow kind of our products to tap into those service providers as well.
That sounds decentralized. I mean, that sounds distributed, but not decentralized, right? So I mean, decentralized to me means more decentralization of power. But it doesn't sound like what you're after is decentralization of power, or is it?
It totally is, I think. Like in this initial stage, I totally agree. We're more so distributed and federated, which is how we're thinking about this phase. But decentralization is ultimately the goal. Like we're playing kind of a coordination role at the moment just to get things working and try to figure out what mechanisms we need in place to be able to step back. But ultimately, that is the goal. Like, we want Infura to be a provider amongst many other providers that contribute to this network in a decentralized way.
I think that's quite a commitment. I mean, maybe a follow-up question here for Fluence and Swarm. Like, one word that we heard a lot is latency. And as far as I know, users care about UX and care about latency. Isn't UX obviously going to get worse because obviously things in decentralized systems are slower and therefore, you guys stand no chance?
Yeah, it will get worse. Yeah.
Yeah, so then everybody will just go back to Gateway and Infura?
So, I mean, first of all, you cannot ignore regulators, right? So, like, if because we live in the world where they own the power and they own tanks and military, right? So they can just come to this room and force us to stop doing what we do. So this is why we have to keep this in mind whenever we develop it, like some new breakthroughs, like in decentralized technologies that gonna enable privacy or anything like that, because they can shut us down kind of easily because they have more power. And I think it's always about finding the right, like the balance, right? So if we build blockchain protocols, the node, it's always sitting on some computer, and computer is physically located in some country where there are some regulations, right? So if US has some regulation against some protocol, for example, then this protocol cannot exist within this country. It can exist outside in different countries. So like it's basically the US citizens will be cut off from the access to this protocol. And unfortunately, they have this power right now. And we saw several waves of kind of resistance back and forth with BitTorrent, for example. BitTorrent Raisin was popular, and in the end, they sort of figured out how to shut it down. Mostly, they shut down indexing services. So they shut down all the resources that allow you to search through content over BitTorrent. So, and this is the reason was that it's sort of the content is illegal, so you're allowed to search through illegal content, so we shut you down. But the protocol itself sort of exists, right? I'm not sure actually how BitTorrent is popular in US right now as a protocol. But it's kind of exists, right? So we facing very similar issues in the blockchain space, especially when we start talking about censorship resistance or privacy, stuff like that. So latency, I think it's always kind of balanced. Like if you want higher latency, you probably would have higher centralization. If you can tolerate lower latency or like some responses that come like asynchronously to the user, somehow basically like if you can tolerate higher latency, then you can increase decentralization, and that's always like this way or another.
I also would like to think that latency is a problem that we do have now, but like we had in the 90s. I remember when I was first connecting to the internet, it was taking me ages to go from page to page, and it was like something that I will never tolerate today. But we are developing it, and we are like trying to improve like second by second, byte by byte, to become always a little bit less to decrease latency, if that is what you mean. So I don't think it is an issue of regulation. It's more like an issue of research and development and putting our focus on that in order to deliver a Web 2 experience with Web 2 tools. And for no other reasons that while opportunities are distributed, like I said, talent is not. Talent is decentralized. So giving all those powers to a single country, that I'm not a citizen of, so I should abide by the law of a country that I'm not a citizen of, is weird. So we should remind that talent is decentralized. Smart people, skilled people are everywhere. So in this way, we should make a technology that is built for everyone and not only for people in a specific given country. Also because, and this is especially true in civil law, tech goes faster than the law. So what we're building out today is not, some of the stuff that we're building out today are not yet regulated, or they're not regulated in every country. So maybe common law is slightly different, but still, like what we're doing today here is something that legislators cannot even imagine. So latency, in a way, would be to abide by the rules that belong to a previous set of technology elements and apply to them today when what we're building is completely different. I'm not sure if that makes sense.
Yeah, I mean, I think it's good to be aware of the trade-off space and then, you know, improve there. Speaking of improving, so I would like to get some numbers from the audience. Who in the audience has used any EVM chain in the last 30 days? Hands up, please. Okay, good. It's just counting how many people are in the room. Now, how many of the people in the room are running their own nodes? Okay, this is a bear market, so committed people are in the room. Still, I just saw rough numbers, you know, under 50% of hands up. I think if this was a bull market, it would be under 5%. Doesn't that kind of mean we still failed? Like, why are people relying on centralized providers? Like, maybe for Gateway and Infura. Like, I know you usually answer this question the other way around, that's why I asked you, but like, does that mean we failed?
No. Like for me also, one of the big things is that still, again, because of the standardization, as standardization becomes better and better and better, even centralized services become less sticky, right? And for me, decentralization is not failed, even if like not everybody maybe in the room is running the chains, but there are like 200 or 2,000 infrastructure providers that each one is centralized, but you can jump between them dependent on legislation or something. I don't think it doesn't have to be like on a node on everybody's phone or a node of everybody's microwave to succeed at decentralization. There should be some good enough level. Of course, if you want to have a really, really good settlement layer, really, really neutral, what's important is not even, I mean, you can always imagine that there's like 1 million people or 2 million people running nodes at home, but all of them are in the same country. It's not good decentralization, if you ask me. Then if there are like 100 companies all over the globe that are running that you can always pick from.
Plurality for the win. So, I mean, I would like to pin you down on one thing you said, and that is that you said, you know, we can switch between these services. Now, you know, operating a project that uses RPC providers at a heavy load, I would say that's actually not the case. Like if you actually use something, for example, sorry to pick all the time on RPC providers, right? But when you use an RPC provider, you think, hey, you know, I have a good deal with Gateway, you know, good deal expires, I move on to Infura, right? And what you realize is this stuff is totally not standardized, right? You get different error messages, which your code cannot handle. You know, one of them has 1 or 2 endpoints that, you know, you didn't thought you need, then you do need it, and, you know, shit breaks up. So isn't there a natural tendency against standardization that helps basically every business?
Oh, can I answer? Yeah, because basically that's a business model, right? So if you're building a business, the for-profit business, that's your like natural goal is to lock up customers in your, like with you, right? So that's what every for-profit business is trying to do. Sorry, Igor, right? But like you need to make money, right? So that's your business model. You want customers to stay as long as with you as possible, and you want to raise the barrier as high as possible to switch outside. And this is actually what cloud computing platforms are doing, and that's what we are trying to address. So I think that overall, like we have this. As a Web3 space, we have this common understanding that probably this is something wrong, right? This overall approach of for-profit businesses, like as like long-term, right? So short-term is great because we have reliable services we can build on. Long-term, I think we all aligned that we want to move towards decentralized networks, and we want to decentralize all pieces of the ecosystem. We decentralized the state via blockchain consensus. We are decentralizing RPCs. We are like DPIN and other networks. So like we are getting there. Like we just need to make sure that we can create a decentralized system that is as reliable as centralized. And this is a question of like research and development.
So what are in this space of bringing us to resilience kind of the biggest problems? Is it regulation? Is it user adoption? Why aren't we there yet? Like after we said, lots of things we can do, why aren't we there yet?
I mean, a lot of these things are, I think like to some extent, we never really like try to purely standardize, and that there's not a lot of projects that like do these things because, again, in the bull markets, everybody is just rushing to pump their token, doesn't really care about any kind of decentralization or values or something. In the bear market is better, but these things take time, and also there should be kind of a demand for that. So it's not only the technical shift. It's also kind of shift on society. And I mean, technical shifts can happen exponentially very quickly. So we can be very, very slow at that, but then invent something and like just explode and very, very quickly do something. But then, like, let's say if you look at, I mean, a lot of people, there's some generation that trades like, I don't know, the whole privacy for dopamine hits of likes on Instagram or Twitter or whatever. And I'm not saying that I'm like not doing that as well, but like there's a lot of like metadata gathering making by these companies, and people are happy to do that. I mean, it's starting to change because people are tired and like of these things, of this total like surveillance economy a little bit, but it like to shift this to make again decentralized and like more private, giving customer more agency technologies, it takes time for people's thinking to shift. And until that, the best we can do is to make it decentralized, secure, and private enough, and just change under the hood because we care, and hope that customers don't care, like the latency increases and other things.
So, I mean, also looking at DIN now, isn't it actually hard to at least even distribute, load in a network that, as you rightly said, is federated with all these different requirements when, you have requirements from the US, you have requirements within Europe, you have probably requirements in Asia. Like, how do you comply with all of that? Like, do you have one global OFAC list from hell that just blocks everyone, or like, how do you get there?
Yeah, that's a really hard question, honestly, and something that we haven't figured out transparently, but we will work towards that. And I think that's like the huge benefit of these different providers and partners that we're working with, is that, like I said, they each have kind of insight from their own geographies that they operate in, and hopefully we can come up with like the least or the most user-friendly way to go about offering those services. At the same time, I think that DIN ultimately wants to provide choice to the user. So I think we can kind of have this like service delivery model where we expose what's available through DIN and kind of let the user opt into or out of various services that they want.
So let's say you have a provider in this federated network that is operating in a country and does not want to comply with regulators, right? maybe there's some rebel providers left. And what is the path of least resistance for somebody who enforces? They might come knock on your door. What do?
Yeah, good question. I think in the federated model where like Infura is playing that coordination role, we are a US-based company, and so we do need to comply with like the laws of the land. But I think ultimately, as we move towards like decentralization more aggressively, I think we can kind of take a step back from that role and ultimately give up control of how things operate so that we're only kind of held accountable for our participation in the network, similar to every other participant.
It sounds like regulator might not just be bad, but provide pressure towards decentralization. So regulator is our friend now? Silence. Friend of who?
Maybe you can twist it. Instead of being a bug, it can be a feature. It's just like the way you approach it, because like I say, you have to comply with the law of the land. So what if you find a way to comply with the law of the land while at the same time empowering people? So maybe that's just like a matter of perspective.
So in terms of Swarm, there's some content that, whatever country you're in, like your project is in, and that content has to be removed. Like regulator comes and knocks at Costanza's door and says, Costanza, this shit has to go. Like, what do you do?
Thank you. So basically, when you upload a file on Swarm, the file gets divided into small chunks of 4 kilobytes. Then the chunks get distributed in the network in a decentralized way. So that means that, first of all, only the owner of the file can do that. And if I'm hosting a file and each one of you has a full node and I'm hosting a file on every one of you, you have a pixel. You have a pixel of a very big picture. So you have no way of knowing what you're storing. That gives you plausible deniability. So in that way, you can make sure that the file stays online. And the file will stay online as long as you will pay for the portal stamps, which is the way to incentivize the network resilience. So yeah, that is how it works.
So bad news for me as a regulator coming to Costanza and trying to take down stuff. Now, similar question to.
Okay, if you're the regulator and you come to me and I'm hosting the file, then you come to me and you make me take it down.
I mean, yeah, it depends if I'm even able to identify where you are, right? So if I'm not, then I can't even get there. But that would be good. So similar question to Fluence. There's content or there's operations happening on your network that as some regulator, I come to you and say, hey, that must not happen. You absolutely must take that down. Like, what's your answer?
Well, basically, Fluence is run by compute providers, right? So they are entities, they are companies or people, and they will have to force the laws of the country where they are located or incorporated, right? Like where their servers located and where they are incorporated. So if the government comes to us, we basically forward to them because we do not own or provide, like our company doesn't own or provide resources and doesn't store data, doesn't make a compute. It's compute providers do it. So, but currently we do not add like any kind of mixing or like some sort of like anonymization to the protocol. It's straightforward. It's like similarly how in I guess storage network that are simpler than Swarm, providers can come to storage provider and say, hey, you have to delete this content. So and they delete.
So is there like a centralized gateway through which these requests go with you, or do users go directly to the providers?
There's no centralized gateways.
So that means bad news for the regulator on your side. You could just say, talk to these, we don't know who's in charge.
Well, sort of, yeah. It's like you definitely will be able to discover who is the compute provider, like where their hardware is located. Like you would be able to identify that, and then you can come to that like IP address and find them.
Okay. Now, if we think about RPC providers, for example, that is, you could say, okay, censor certain IP addresses, censor certain Ethereum addresses. When Roman wants to know how many ETH he has, unfortunately, I guess Infura is not allowed to tell Roman anymore because he ended up on the OFAC list, which is an absolute disgrace. But so in the RPC space, it is also more complicated because there's order flow, which is, pending transactions, which is coming in and which is then being forwarded until it ends up in a block, which also, and again, has some kind of censorship implications there. Can you walk us through what is the current state of affairs on that side?
So again, I mean, we ourselves are located again as a company in the Nordics, in Norway, which is EEA but not EU, which is gives all sorts of things. I mean, we don't have to comply with some of these regulations. On the staking side, it's mostly up to clients, because if we have a client, let's say, in a customer in the States as a state entity, I mean, we have to run staking for them with the compliance, because otherwise they get in trouble. We will not, because we are outside of this. For like other customers, we don't do that. And on the RPC side, we don't censor because, again, we don't have to. If the regulator comes to us and tells that we have to, I mean, there are a couple of ways we can handle that, but most likely we'll have to comply with the laws of the country we are in. But yeah, but on the other hand, let's say our data centers, they have to comply with the laws of the country they are in. So it makes it a little bit both interesting, because yeah, we can always do some legal things there, and more complicated because you kind of have to comply with two countries at once. At least you usually have a data center plus Norway with us in terms of compliance that's necessary, plus the customer's compliance. But we really, really want to make sure, especially on the staking side, that like we protect our customers. They shouldn't get in trouble in there, because they're usually located somewhere. Also, like they shouldn't get in trouble for the operations they do with us.
But do you work with any, like, I don't know, forward your order flow to some block builders directly or something like this?
We do for some customers, for some we just do block production ourselves. It really depends. It's again, for the customers in the States, they require this thing. We have to go to basically MEF boost and block producers, because it's the simplest way to comply. For the rest, is just a question of mostly efficiency, because again, for better or worse, the block producers, if you outsource block production, you get better blocks on staking. And then for some, basically if the customer care for optimizations of revenues, which a lot of them do, then block production is usually outsourced. If they care for neutrality, then we don't. By default, we don't, unless they ask.
Cool. Now, to wrap it up, everyone has one wish that you can, make to Vitalik or whatever. So what do you hope you get within the next 12 months? We come back here in 12 months, and what is your wish for this infrastructure ecosystem that we thought about, Vitalik or whoever? You have one magic wish that we should have achieved in 12 months from now. What is it?
Oh, I have very specific need. So this new wave of great, amazing rollups and ZK rollups generation, we just need it to be mature as possible, so we can run our own application-specific rollup, because we need cheaper transactions for Fluence network. It's like so, so like we spend a lot of time on iterating on rollups, and they're almost kind of ready for usage in production. There are some of them that are ready, but not many. So we wanna run our own rollup and make it like to work. It should work.
Make rollups great.
Yeah.
Again. Other wishes?
Yeah, like I'll just join because we also run a lot of rollups, and for me, since I'm very bullish on ZK, I want the proofs to proof generation to become cheaper and more efficient. Like we already have a really great progress on that. Just to give you like numbers in perspective, to run like a ZKVM prover on Polygon ZKVM again, because that's what I know about. In February, just before the mainnet release, you had to have like 1.5 terabytes of RAM per each prover. Now it's under 500 gigs, just a little bit later, and the work goes that you eventually can run even then on the Polygon ZKVM. You can run provers from your computers with maybe 32 to 64 gigs of RAM. So when it happens, it changes things dramatically, because right now the the biggest hurdle of running your own really good ZK rollup is the price of a prover if it's your own rollup. Like it doesn't really matter in terms of you running the ZKVM mainnet, the shared thing, because the amount of transactions there is enough to offset this cost. But if you don't have enough transactions in there, then the prover cost is kind of outweighs pretty much everything else in the infrastructure. So if we can bring it like down fourfold, I would say it's gonna be pretty good.
If I had to come back here in a year and make a wish, I want Web3 to be a reality and not a spectrum. And that means from the centralized front end to the storage and communication layer, and the big elephant in the room that we never speak about, which is ISP. Because they are still decentralized, and we are still not working on it. So yeah, full Web3 adoption without AWS, Google, Microsoft, Oracle, or telco providers in between.
Yeah, I would echo your thoughts exactly, and just say to you, I think like increased collaboration at the RPC layer is kind of the goal for DIN itself, and kind of something that I think we're really hoping to foster. Like you said, like standards across RPC providers, they're tough to come by, or they're tough to kind of be adopted, and we're hoping that through DIN we can kind of set like a level playing field for many different RPC providers to collaborate.
Great. So that was something from 4 amazing projects. I am hopeful that in 12 months from now, for everyone in the audience, that we uphold the values of Web3. Web3 is not to make all of us rich. Web3 is technology that empowers the individual. And I know in 12 months from now, this room is going to be much more crowded. There's going to be much more NFT tourists in the room again. And I hope that everyone who's here right now can uphold the values of empowerment of the individual. And with that, I'm looking forward to many more sessions that help us get there. Thank you so much.
Yeah, one correction, 5 great projects on this, not
yeah.
4.
And we there's food outside, so everyone has put up with a long day so far. So grab some food and take a break before we get back into it again in about a half hour. Thanks.
care of all of the management, so we could simply focus on the work itself. As soon as we started, we were building and running workflows that made it really easy for us to work together. It's such a visual platform.
Her passion lit the way, whose dream has become his nightmare. your love. I'm in need of your touch. Baby, I've been gone for a minute now. Got me all alone and I'm singing now. Oh, oh, jumping up and down. No one else around. Singing out your name in this sound.
down because you chose to waste the day. She drove through the darkness, her passion lit the way. Whose dream has become his nightmare, his duty, and his mission.
I know that I will lose my mind if you tell me you're not here to stay.
We're going to get started in a minute. Crystal, 1 second here. I will introduce you in a second, but I want to give another shot to get some more people in here. So give me 1 second.
May I test a bit?
It's going to work.
Okay.
Yes, I say the bar is in here.
Free flow.
And kill the lights. All right, well, I was killing the lights in there. It helped a little bit.
Did you share that there's free flow?
Yeah, the mic didn't work in there, so it wasn't as successful. So,
Thank you.
listen, we're getting started the last session. I think we can tell that right now, the last home stretch, and Crystal is kindly kicking it off. So let's welcome Crystal and get started here. Thank you.
Well, hello everyone. Thank you for being here. I'm in stuff dinner for now. I'm Crystal, presenting from BD Lead for Map Blocker. Today I'm here to share with you building the ultimate map protection RPC. Map Blocker is the #1 RPC for map protection. It is built by the OG experts of MEV in the supply chain, including Agnostic Relay, Beaver Build, and Cowdow. Today we'll cover what is MEV, why does it matter? Maybe raise your hands if you still have some energy too, if you know MEV already. Okay, great. Then I can save my voice. We'll do a quick recap here on what is MEV. Well, MEV is the maximal value that can be extracted. Maximal value that can be extracted by block producers in the blockchain network by including, excluding, or changing the order of transactions in the block. When a user submits transactions in Ethereum, it first goes through the public mempool, which is a collection of all the pending transactions. Validators then pull the transactions from the public mempool and add them to the block when it's time to build. Historically, block producers would order the transactions by order of gas fees. But when MEV searches comes in, block producers are now extracting additional value by taking advantage of the ability to reorder transactions. Searchers look into the public mempool and pricing and the timing their transactions accordingly. They create these bundles and then pay the validators a higher tip in order to include these transactions ordered in a specific way. These searchers typically run algorithms to detect these profitable MEV opportunities and run bots to capture these profitable transactions at the expense of the users. So there are different types of MEV. If searcher pays to have the transaction go before the user one, it is a front running. It is harmful because, well, the users lose the opportunity that they detected first, or they lose the ability to execute the transactions completely. Back running is harmless one. Searcher pay to have their transaction go right after the user's one. It's harmless because it doesn't affect the user's transaction itself, but then they're trying to capture the price impact of the user's transaction. The worst of all is what we call a sandwich. It's a combination of both front running and back running. Well, who in here has been attacked by MEV before? Raise your hands. Okay. Well, the good news is, or those people who didn't raise their hand is probably, why don't you find out? Go to zeromath.org, an organization dedicated to MEV research. Well, you'll find out whether you have been sandwiched. While ignorance is bliss, we can look into a block analysis to find out here. Here, you can basically find out whether you've been sandwiched in two main ways. One is if the transactions are not ordered by their natural gas order, so typically the highest gas fees will come first. Then there's a high likelihood that there's an MEV attack. The other way that you can detect an MEV in a block analysis is if you see the same trading pair being traded multiple times in the same block. Here, the actual user transaction is the middle one. The user is trying to swap WETH to DAI and Uniswap v3. But then it got front run by a searcher, and then thereafter a reverse trade DAI to WETH as a background. This, my friend, is called sandwich. Well, this sandwich caught our friend here $15 US, which is not bad. It's a mini sandwich. But well, while this is a mini sandwich, let's look at what can happen when it comes to a professional sandwich bot here. Jared from Subway, known sandwich bot, according to Eigenphi, which is a data platform that conducts data analysis on MEV, he has captured a profit of 6.3 million in just 3 months. Well, this is just one MEV bot. Imagine many more MEV bots and many more blocks over the network every day. It matters because it's essentially a hidden tax on many types of Ethereum transactions. Whether the user is trading on DeFi or selling and buying NFT or lending tokens in liquidity pool, there's a chance that these MEV bots will opportunistically take advantage of it, manipulate the trades, profit from them, result in failed transaction, unfavorable price, and making users trade worse off. And to date, MEV has been responsible for more than 1.3 billion lost on value for Ethereum users. Well, enough of the problems. We're here to talk about solutions. Building the ultimate map protection RPC. Fortunately, there are a growing number of map protection RPCs. These are the top ones. Number one is Map Blocker. The next one is Flashbot Protect and Blink. There's also a lot of map protection aggregators here. Llama Notes, Block Native have included Map Blocker into their RPC aggregator. Blocks are out here too. Today we're focusing on the details on how Map Blocker is designed and built to make it the ultimate map protection RPC. Let me give you an overview. Map Blocker is an RPC endpoint that aims to protect users from front-running and sandwiching attacks, so the harmful ones, and then give users a kickback from back-running opportunities created by the user's trade, so the harmless one, and speedily settles the transactions. Here's the order flow logic for Map Blocker. Well, starting from the left side. User submits a transaction. The transaction first go to Map Blocker's private mempool, where Map Blocker's system would decouple the user transaction into two parts. One part is the payload, and the other part is the signature. Then Map Blocker system shares the user transaction information without the signature to all searchers connected in the network, along with AI-generated noise transactions for preventing probabilistic attempts by searchers in exploiting the order flow. Map Blocker system proceeds then gather these kind of, what it does is it auctions off and the searchers would submit bids for the right to background these transactions. The winning bundle is decided by one that gives the most value back to the users. Map Blockers then proceeds to gather these bundles created by searchers and then add the signature. And then forwards the bundles to all the major builders in the network. Builders select which bundles to include into the block, and once it's included, 10% goes to the builder proposer validator fees, to quickly include it into the network. The 90% goes as a rebate to the user or the project connected to map blocker when the transaction in the block is executed. Let's take a close look of the design choices we made. So instead of sending your transaction to a public mempool, which is prone to MEV, or to a private mempool connected, that is, well, okay, so basically, it connected to private mempool, it is therefore de facto protected from any harmful MEV. Then instead of losing money to searchers, what you can do now is earn money from searchers. You get rebates from searchers that are connected to MapBlocker because MapBlocker auctions off this right to background to the searchers. Remember, 90% of it goes back to the users of the projects. Strong network of builders instead of single builder. So instead of sending to a private mempool limited to one builder, MapBlocker effectively acts as a builder aggregator, aggregating all the major builders that controls 95% of the Ethereum blocks. This secures fast inclusion time. Instead of some RPC endpoint which leave the users a lot of technical decisions, for me, I'm not super technical, it helpfully helped me decide on all these decisions already. For example, users don't have to choose what kind of builders, new builders out there to connect to. MapBlocker decides, create this list, and vet for you. We have very simple defaults. So by default, we go to the fast RPC. So depending on your needs, fast will allow transactions to get on chain as fast as possible, while also generating backgrounding rebates. While the no revert focuses on making sure that there's no revert possible. In case your transaction is no longer valid, it will stop being broadcast to builders at no cost to the user. If you are super mindful of your privacy and want no searches to look at your transactions, you can take the full privacy endpoint, which focused on getting transactions on-chain directly via builder. This method does not offer a rebate, but well, this is your full privacy endpoint. After all this, why is MapBlocker better? Well, for one, we have superior rebates. MapBlocker is designed to be very easy for searchers to integrate. Unlike MapShare, MapBlocker does not require a new on-chain search logic based on a very limited public information. Traditional searcher algorithm is sufficient to integrate with MapBlocker. What it means is that searchers find it very easy to onboard into MapBlocker. It means that there's a robust competition for searchers and drives superior trade rebates. In fact, it's 10 times better. How so? 600 Ethereum has been returned back to users and in projects already. And that is 10 times more than any other solutions in the market. Low latency and fast inclusion time. Remember, we're submitting to builders that control 95% of the Ethereum block. We also vet them all the time. What it means is that 90% of the transactions are processed in the next block within 12 seconds. If not, very, very likely the block after. Built by experts with deep know-how. MapBlocker is a collaboration project by Agnostic Relay, Beaverbuild, and CowDAO. MapBlocker is built by all the OG experts of MEV supply chain. Well, this guarantees that it is technologically sound. Overall, MapBlocker has the best speed, balanced with best protection, and offer, remembered, 10 times more rebates. Here are some stats. Since our launch in April this year, MapBlocker has already protected 24 billion DEX transaction volume, over 9.5 million transactions, covering 440,000 users, generated and growing rebates to users or projects. So why with users or projects is that if your project is submitting order flow to MapBlocker, you can add the referrer to capture the rebates yourself instead of the user. Now, some closing note here. So, well, you might think, why not just send to multiple endpoints? MapBlocker sounds great. That's what most people tell me after my BD call. It's like, oh, MapBlocker sounds great, but then I don't know why somehow my project's already submitting to Flashbot. Great. Why don't I just add MapBlocker and submit to both? Well, that sounds in principle great protection. In fact, it is. To say it's not ideal is an understatement. When you're submitting to both MapBlocker and Flashbot Protect, you're risking leaking information benefiting the searchers. Remember this. Flashbot's privacy model relies on sharing very limited information about the transactions, making it super hard for searcher to front run out of the bundle. MapBlocker shares practically all information about the transaction, and additionally use some AI-generated noise transactions to distract them, to prevent them from exploiting the order flow. Now, let's say you're a searcher, you're listening to both MapBlocker and MapSearcher. What will happen is effectively, great. You can get a way around the system, both systems, in fact. MapBlocker will tell you all the core data that Flashbot is trying to hide, and Flashbots will tell you, hey, these are the fake transactions, these are spams. And effectively, what it means is that you're left with much less protection. Sending through an RPC aggregator is acceptable if they channel to MapBlocker and only to MapBlocker. But if they, again, send it to multiple endpoints, the same privacy leakage happens. And if they end up sending it to an inferior version of the map protection RPC, then I'm sorry, you won't get rebates and you have much less well protected. Well, Ethereum's MEV challenge is a testament that to the complexity in building decentralized, secure, and fair blockchain network. While MEV does pose significant challenges, MapBlocker is here to offer opportunity for us to collaborate and basically protect the users. These are some of our partners, and it's continuously growing more as MEV problem becomes more and more known, and for everyone here as well, we'll be able to collaborate together and make this place a fairer place. These projects prioritize the user's interest first and integrated the best map protection RPC. Okay, so we welcome you all to join us. As users, you can scan this QR code on the left, and you can integrate the RPC within a minute. And for wallets and Web3 infrastructure projects, you can add me on Telegram. I'll be here all week to make sure that you get integrated ASAP. Thank you everyone for your time and appreciate your evening precious time. Thank you.
Great. Thank you. Time for one, maybe two questions. Do we have any questions in the audience? I think the presentation was so clear that no one has any questions.
I'm sure everyone would have MapBlocker.
And so the answer is, does everyone not have, if everyone not uploading or downloading MapBlocker, then clearly you have questions. So I assume everyone here has downloaded this, right? Okay, good. All right.
Thank you.
All right, on to the next. We have Yar, is that right? Yar? Yep. Yair. There we go. Come on up. Welcome. There you go. Grab that mic. Thank you. Fantastic. Welcome. So give a little round while we get him set up. So welcome. Thank you.
Thank you. From the other side? So hi everyone, I'm sure you're having a very long day, and thanks for the technical team here helping to set it up. Even the computer is a bit tired, right? So my name is Yair Klepper. I'm a founder of Lava Network. We're building a modular infrastructure supporting any RPC APIs straight from the browser. So let's kick it off. What about serverless? Right, it's a concept that constantly we've been promised since the beginning of Web3. But once all the Web2 infrastructure are supporting the following logos and players, does it really serverless? So let me take you to the amazing project we've seen today and protocols that building RPC. RPC basically is the remote procedure call, is the basic layer that we can interact immediately with the blockchain itself, right? Read, write data straight from the browser. But all these projects, right, are promising us that they have a serverless component, that from Lens protocol to Twilio, and this all bring us serverless infrastructure. But what I would like to talk to you about today is that this is a myth. Every indexer, every RPC provider, sequencer, they're all actually centralized. None of them is straight from the browser, and every dApp today, especially in the multi-chain world we live in, all believe in, are actually running their own nodes, running their own servers. And we see that across super and many different dApps today, from wallets, DEXs, SEXs, everyone today, when you open your wallet, you are going through an RPC call, which is not really serverless. So what is the options now? When 1,000 more chains going to appear, we see all this immense amount of L2s and rollups. We see that you'll need more data. More and more data means we need a much more scalable infrastructure. And those are the options today, the possibilities. How do you get access to this data? So if there is a new chain coming up, you need to run a new RPC node to support it. But is it practical? There are 3 ways today that everyone here is using the data. One of them is to run their own nodes. The second is to query the public RPC of every ecosystem. Every ecosystem supports public RPC, its rate limit, and honestly today we all know that this is kind of the backyard of every ecosystem. Because nobody wants to support it. Usually you have contracts that are locking down the ecosystem for a long time. And at the end of the day, the rewards are being spent and split at the end of the month, not because of the quality of service. The last way to get the data is obviously to use the amazing centralized provider. And we see a shift here. Every centralized provider almost is going into a decentralized way, much more secure. But if we all remember the principle of blockchain, running your own node means a permissionless way to get your access, to know that it is actually accurate, to have your privacy, and not to have a single point of failure. This is not what we're having today. Moxie said, and help us understand that we want to build Lava, no one today wants to run his own server. Nobody wants to run his own node. And the fragmented ecosystem that we have today in blockchain doesn't help us to scale. Those are the amazing first pioneers that really reduced the barrier to entry, right? They said something very simple. Don't run their own node. We're going to do it for you. But when you know today that there are enterprises, and at the end of the day, they need to show profit, everyone is choosing, according to his business, what to support. Alchemy supports 9 chains. Infura supports 14 chains, and so forth. So it's not really sustainable. What we believe in, Celestia, we take it for the credit from Celestia, is modularism, not maximalism. So we thought about a way to build infrastructure like Legos. Anytime that somebody is spinning a new chain, anyone from the community can come and simply build the specific APIs, the specific specs for that. And this is what is Lava. We're building a modular infrastructure that can harness the power of community. Everyone can join permissionlessly and start serving while getting the accountable for the data they serve. And at the end of the month, they receive the rewards based on the quality of service, not based on their branding. So even a small community node runner can join. And we just have an amazing example from last month. I'm going to talk about it later. So Lava introduced this concept that we call it specs. And specs can be anything. Can be a simple implementation of Ethereum, some APIs that you want to support there, any rich API that you would like to take. And everyone can build that exactly as Legos. Today, adding new spec is becoming super, super easy. And I will show you a video just in a second.
Create your credentials and log in. Using Lava SDK on the front end is rather simple, but requires the use of our gateway. Visit gateway.lavanet.xyz, create your credentials and log in. Once you've done that, you can create a project. Give your project a name. Here we'll use Start X Lava. Select the API accesses that you want. In this example, you use both StarkNet and Lava. Your project will be created. Once your project has been created, you can open your project to review what API accesses, as well as check out the endpoints that are readily available. If you want to use Lava SDK, you can click Use Lava SDK on front end and review. In reviewing, you can see how the project ID is used in the various API accesses to uniquely identify your project. This allows you to use the Lava SDK without inputting any credentials. You see that the project ID is part of the badge that you'll be giving to the Lava SDK once you instantiate it. Now we can go about the creation of our project. This project will use the API accesses we just made. The first thing that we'll need to do is actually make the project. I'll do this on my machine by creating a directory. The name of this directory will be Start Example. We're going to make sure that we're inside the directory, and then we're going to initialize it. And we'll do this using the npm init command. The npm init command gives us the opportunity to create a package.json. And then we'll npm I lavanet lava SDK. We'll use the node package manager to install Lava SDK. You can of course use yarn add command as is shown here on the gateway. Once we've installed the package, the easiness, the fun begins. So let's go ahead and get that installation started. It should only take a moment.
You counting, guys?
Great, our installation looks to be successful. Now let's go.
Yes, so it's that simple. In 5 seconds, you can install the SDK and get a peer-to-peer access straight from the browser. So what is Lava? Lava, it's an app chain built on Cosmos SDK. We wanted to allow every dApp to be able to get access to not one provider, but the top provider straight from the browser. And we're doing that, but every provider can join Lava. Run a simple Docker, 5 minutes maximum in order to sign up on Lava and start supporting nodes on every chain. Today we support 30 chains, but obviously once we're going to go mainnet, there is unlimited amount of chains that we can support. So a dApp using only one subscription in order to get access to all the universe that Lava and the provider represents. So we started by the simple query. Once they have anyone has a need to request to get some relays, immediately Lava is pairing on-chain to the best provider by region, by quality of service, and by score. This is how we ensure that there's no any middleman between the dApp and the provider, as if you were going to any centralized provider today. This is the same as how you use the Lava SDK. Once the transaction is done, Lava is signing the transaction, the dApp is signing the transaction, give it back to the provider, and the provider coming back to the chain in order to collect the rewards. Rewards are distributed once a month, and this is how we can actually take accountable each and every provider doing this route. Once we implement the session between the dApp and the provider is being done for 15 minutes, and this is allow us that if there is a downtime between the provider and the dApp, automatically we revert you to a new provider. So dApps that using Lava today actually saving up to 50% of the infra cost. And this is because they don't need anymore to be implemented and to trust their node runners, they're running their own nodes. They don't need to implement backups, disaster recovery, and so forth, and load balancer. So this is only the amount of code you need in order to implement Lava. Obviously, we're supporting the best JavaScript libraries today, Cosm, Ether, and so forth. I'm reckoning after the lecture to go see the docs. Super elaborated, and the team put an immense amount of work. So yeah, that's in general what is behind the Lava SDK. We implement super cool concepts from badges that are actually hiding the private key. Obviously, when you contracting and communicating peer-to-peer with the provider, there is a possibility of a leakage. So we introduced an amazing concept that's called badges. So it's actually running your own server that encrypting the key straight from the browser. There is other amazing thing like constant availability. It means that Lava is a blockchain. As a blockchain, we also can go down. But if we go down, you still have service. And we're doing that because the list of providers is being spent and being saved all the time in your SDK. So even if the Lava blockchain is down, once it's going up, provider can come back and request for the service they made. So we are live now. At the beginning of the year, we launched the first version of the testnet, and we see an amazing growth within the dozens of dApps when they use the service. And also, it's also a testnet. So we went to the best providers out there and start working with them directly in order that we make sure that this is super scalable. So we're working with Blockdaemon today, BeWell Lab, Coder, Chainstack, and a list of top providers. That's only some of the ecosystem that we support. We have currently 30 different ecosystems and counting. But the concept that we introduced just 2 months ago is the first product of Lava. You remember at the beginning I talked about public RPC. But ecosystems started approaching us and asked us, can you replace this public RPC? So we came up with a new concept, and we call it incentivized public RPC. Basically, every ecosystem can pull rewards, and every provider can join, whether the huge providers that currently end contracts with the ecosystem, or any small node runner. From even running 1, 2, 3 nodes at your home, you can join. You're listing in 5 minutes, you're signing up to Lava, and the chain itself providing rewards to make sure that they are split equally at the end of the month according to the quality of service. So remember, we went from just contracting and race to the bottom in the RPC prices to quality of service. What you gave, what the service you got, this is what you should get rewards. The concept is already live 1 month in Axelar, in Evmos, and we just started with Axelar. We see more than 70 providers joining, providing amazing service, and actually, as I speak, the first distribution rewards should get to the providers. So we're super excited about that. It brought much higher quality of service and performance to those ecosystems, and we're just starting. We just signed with Near, and going to share more details soon. So once we understand that RPC is super important, RPC is the entry point of every ecosystem. Because developers, when there is starting to develop something on an ecosystem, any project need the RPC. So immediately they go to the public RPC. But what about APIs? What about indexing, sequences? I've seen an amazing example here in the presentation before. We can leverage that. So the next concept Lava is building is a modular API, rich API. Everyone can list his own API and start receive rewards for the API that somebody else used. Doesn't matter what's your region, where in the world, but you can add to the top of that. So one of the example we just launched is a Subsquid, and I think we are a bit short with time, so I will keep the links afterwards and invite you all to join our Discord, guys. Join our Twitter and follow up, because we soon gonna announce our roadmap to mainnet. Thank you.
Great. Thank you. Thank you. Do we have questions? Is everyone here ready to be a node runner for Lava Networks?
What do you mean? They all are.
I hope so. That's why they're here. We must have any questions. Yes, we have a question. All right.
We just need the first non-shy person, and then.
Hello there. Is it possible to have any configurations, for example, the number of requests per second that our limited node, which we are running around on server, can provide to Lava?
Can you repeat? Sorry, it was a bit cut off.
About the configurations, about the rate limits that we can provide to Lava.
Exactly. So, the specs allows you to do a specific configuration according to what you want. You deciding as a provider what you want to serve, what you can serve, what your machines that you're running are able to serve. And this is the same way that you're going to get scored accordingly. So, for example, if you are not supporting above throughput and latency, Lava will not revert these dApps to you because it knows that you cannot actually provide the service. I hope it's answering the question.
Hi, thanks for that. Just one question. You talk a lot about quality of service, and I'm curious how you define quality of service and how you kind of enforce and measure it.
Great question. So our amazing engineers, we today 24 engineers, and the most of the background we bring is from Israeli military army, cybersecurity, and cryptography. They've been working on that day as a night in the last 1.5 years. We wanted to keep it simple for the user, for the dApp. So this is why we're not taking any step in the middle. We're not serving as a middleman, but we're collecting the data during the session. During the session between the dApp and the provider, we collect all the parameters. We collect the latency, availability, if they have downtime, the regional presence, and a long, long list of parameters in order to score the provider. Once the dApp is finished the transaction, is signing on that, so we know that it really represents the real parameters, and the provider cannot change that. We just post in our forum an amazing passable of quality. So I really invite you to go there, dive deep, and obviously ask any question in Discord.
Yeah, hello, sir.
Artyom from Decentralized. We're actually one of the API providers in our infrastructure. Yeah, I should contact you definitely. But I was wondering, what, from the DApp perspective, what I should pay for, or if I have some specific needs for my DApp, like the best speed, the best services, or just Lava pays the data provides, and that's it. I mean, in terms of economy, how it works.
So I think one of the greatest things here is that the pricing is based on the supply and demand, and we're going to introduce shortly an amazing dynamic pricing engine and stuff like that, that based on where the service is requested, the demand going to also increase the pricing, and the dApps themselves can flag if they want a specific provider that they already worked in the past. They can flag if they want a higher throughput. They can subscribe to the premium services, and everything is on-chain, so super, super simple. In our mind, we were thinking about the fact that if a dApp wants to go multi-chain, and every successful dApp wants to do it at one day or another, they need to have one subscription, and they can get access to all Web3. Guys, thank you so much. I'm here, and we have swag. I love you all. We love you all. So please come and take it.
Great. Thank you. Your round of applause again. And we have a flip-flop in the schedule. We're looking for Warren to come up and take the next slot. Coming in straight, I think your presentation is almost ready. So Warren, welcome to the stage. And by the way, questions not being asked right here on this barcode. Please get on it and fulfill your quota of anonymous questions. You're not allowed to leave the room unless you've submitted at least 2 questions. Please, we will be checking. Warren, welcome.
You can start and I can, if you want. Yeah, you're good.
What? There we go. All right. Yeah, sorry I'm a little late. Well, actually, I was called early, so I ran over here.
You're right on time.
The street. Whew, I was hoping to get a little breather before, but I guess not. So happy that you guys are still with us. I know it's been a long day. I promise there will be memes in this slide, so maybe you get a breath of fresh air. But my name is Warren Paul Anderson, the co-founder of ExoCore. It's a brand new omni-chain restaking protocol. So we're so new that when people ask us what stage we're in, I say we're pre-swag. So we actually just published our white paper yesterday. My co-founder, RJ, is in the crowd. RJ and I have been operating in the space for a while. I was a little nervous to come here because when someone told me all the RPC providers under one roof, I'm thinking, who's keeping the lights on? But we definitely appreciate, this crowd big time. RJ and I have been in the space for, I've been in space full-time 10 years. I think RJ's been in for 5-6 years. We spent a lot of time at these big companies and networks running and building a lot of RPC infrastructure. so we empathize, with the pain points. We have our share of war stories. That did not come through. It makes me nervous for future slides, but it says RPC down, or it should say RPC down. So I think everyone here has like some war story where, the RPC network's down, people think the network's down, and that's pretty much the case. So lots of stories on that. So I'm here today to kind of talk about restaking and how it can help to secure decentralized RPC networks. But before I get into what restaking is, I want to share a little bit about why restaking matters. How many have heard of restaking before? Okay, so unless you've had your head in the sand for all of the bear market, I'm sure you guys have heard about restaking. So I won't get into what it is yet, but I will talk about why it's important. So classically, proof of stake consensus has kind of taken the lion's share. I think post-Chappelle upgrade, it's official that proof of stake is going to be here for a while. It's been very experimental the last several years, and now it's kind of, I would say, is production ready. Classically, you have, I don't really need to communicate to this crowd, but you have stakers that are pledging their tokens as crypto economic security to secure the networks of dApps. This is great for the dApps. You can be a dApp and deploy very quickly. There's lots of tools. Solidity is becoming a lot better to work with, and this is just like a new paradigm for programming, right? The ability to write applications that are effectively unstoppable. That's very powerful. But we also think about what does it look like if Web 2 developers coming into Web 3, what are they going to are they just going to go through and start building dApps? What kind of infrastructure they need? But there's some problems kind of with this model, right? So there's a whole new kind of growing category in the restaking kind of space we call actively validated services. It's just another acronym to memorize. But actively validated services are effectively services are offline. They're providing services to dApps, to other infrastructure providers, classically Oracle's bridges, sequencers, you name it. There's basically a whole category kind of growing of that. We also kind of look at RPC in this category too, and I'll explain a little why. So RPC, obviously, or any AVS, like they're tasked with effectively trying to bootstrap their decentralized security, right? So how do you actually inherit decentralized security if you don't have active validator set, if you don't have a token, et cetera, right? Well, it's actually pretty difficult to do. And I say this with experience, having built multiple L1s before, but the process goes as follows. You design the staking token, you recruit the validator set, you attract the stakers, and you hope that you can build some liquidity, and not only build liquidity, maintain liquidity through the ups and downs of the market. This is not trivial. Like this sucks. Like, trust me, it sucks. And there should be like a better way of doing this. And this is completely unrelated to your product or service. So building a token network and everything is basically introducing a product and having to maintain it at a high cost of maintenance, high cost of bootstrapping. And then when you go live, you have that product. And then if you're, for instance, if you're an RPC infrastructure provider, then you also have that service. So we all know that startups usually can't get one product right, let alone two. So this becomes like extremely difficult, right? But there's market pressures for going through this process, right? The community, the market, they want to know when are they going to have their incentive kind of come through, and we understand that, we recognize that, and that's okay. So there are cautionary tales, right, in this market, where there's a lot of, and I won't share whose market cap this is, but you guys could probably figure it out. You have effectively, a token launch, TGE, where everyone's hyped, the investors are great, the cost of corruption, which is the cost that an attacker, or cost to attack the network, is high, the network's secure, and all of a sudden there's this death spiral that happens, right? And the price of the token collapses, the market cap collapses, all of a sudden the cost of corruption goes really down. And the problem is you're bleeding users, you can't retain users, you can't recruit new users. Everything's is problematic. This is not a good situation to be in. And it can happen by just launching your token network too soon, right? Classically, tokenomics, a good tokenomics design, you have some type of user base, you have maybe product market fit, people like your stuff, you've reached your like 1,000 people of like your community, and there's maybe even a business model in there where you're making money. If you don't have any of these things, you may actually face death, right? Because if you go to try to launch your network, this is likely what's going to happen. And I think we all know lots of projects in this category now. Now, I'm not here trying to preach and convert you all to no-coiners. This is not my intention. I think there's lots of room, and still lots of room for new tokens, even though we have thousands already. But I'm just saying that there is another path. There is another alternative. And I would equate doing this process with really buying your crypto economic security. You're basically investing in this future of bolstering a network, and it's going to be decentralized, et cetera, and we all hope that that will happen. We hope that you don't go through the death spiral. We hope that number go up. Good job, right? But there is another alternative to buying crypto economic security. You can simply rent it through restaking. So finally, what is restaking? So restaking was recently introduced by Sriram Kannan, the founder of Eigenlayer. He's been working, on this kind of core problem for a long time, kind of put restaking on his shoulders and created the market. We're really appreciative. We think it's going to be massive. But restaking, kind of taking this existing flow where you have your stakers, it's all about just extending your crypto economic security to this category of AVSs, which includes RPC networks, so that you can provide and you can consume and rent the crypto economic security instead of having to actually buy it. And this is important because that gives you the ability to focus on your product or service. I mean, think about it. Like in Web 2, you go into AWS, you spin up an instance, and you start building, right? But imagine if you had to buy a data center just to get your app out in the store, get your service done. That used to be the case. Thank God, we don't have to do that anymore. We think that we're still in that. This is like the Web3 equivalent of having to have your own data center or have, effectively bootstrap your own TCP/IP network in Web 1, right? We're in that phase now. So we want to migrate to a phase where we can rent this and buy maybe later, right? So the benefits of restaking for an AVS are that it helps to validate off-chain operations. It incentivizes honest behavior. It disincentivizes dishonest behavior, right? And this is really the crux of crypto economic security. Man, the PPX just totally torched my thing. Anyway, so this is basically the crux of what crypto economic security is, right? These three things. And now with restaking, you have the ability to rent that from day one. So what is ExoCore? So, not too long ago, RJ and I were talking about, the restaking and just as a new concept in crypto. We had both left our previous roles. We were looking, for kind of something that we could really focus on in the long term. And restaking we identified as a new category in crypto. It has all the markings of, solving a big problem. It has a value accrual to the L1s, which is always good. It creates new economic opportunity. We think this is something that's going to play out long term. So we were inspired by Eigenlayer, obviously, and what they were doing. But we wanted to kind of start from first principles, answering the question, what would an omni-chain restaking protocol look like truly chain agnostic? And we came up with a solution. It's basically Tendermint-based consensus. We use ZK Lite client bridging to do the messaging with various L1s. This allows us to deploy these smart contracts. L1s are very lightweight. ExoCore as a protocol takes on a lot of complexity to handle the restaking operations. You can think of it as like a domain-specific restaking protocol. And that gives us a lot of freedom to be able to kind of horizontally scale. So going back to this ugly slide, that's kind of the core of what we're able to do. We're starting to roll out on EVM networks first. We can theoretically support any network with very minimal changes to the core protocol. So it's built with that horizontal scaling. So this is just a kind of more zooming in what the architecture looks like. Like I said, Exocore network handles a lot of the operations through different modules. So deposit module, withdrawal module, slashing module, operator modules for registering, delegation, AVS module, and finally the reward module. We can, like I said, deploy on different chains. We view chains as kind of like client chains in our interpretation. And then we can communicate with those chains via the ZK bridging. Now we kind of lucked out. We are using layer 0 with Polyhedra. Polyhedra is a pretty new project. I've been working in ZK research and development for a while. We're very lucky that there's an implementation of ZK that's actually working. It's scalable enough. We use it in a unidirectional way, so we actually, it would probably be too costly to do it bidirectional. So we just happened to luck out. So a little bit how it works. So basically there's different operations in this flow. The restakers, they send a transaction to deposit their addresses. This gets received by the client chain contracts. The vault stores a deposit, and Exocore reads this event through the ZK light client bridge. Then it confirms or rejects the deposit. We send a TSS transaction back to the L1 to confirm it. Now, what can be restaked? So classically native tokens, Ethereum, AVAX, Pol, BNB chain, you kind of go down the route. Liquid staking tokens, so this has become pretty popular with STETH, RETH, and SAVAX, etc. We haven't seen DeFi LP tokens yet, but we anticipate this will happen. So just fill in the blank there. So this slide actually is kind of most relevant to this room. So the AVSs on the system, we kind of break everything down by tasks. These are like the operations that an AVS is being held accountable for, right? So classically, a task can be executed. The task performer will save that to storage, broadcast the result of the task, verify, attest it, this is the result, and then finally the submission of a reward claim is done via a 2/3 BLS aggregate signature. And that's done through the rewards contract. It's a very similar flow for slashing, so this kind of same operations. And if you have more detailed questions, the man who really designed this is sitting right there. So classically for reward distribution, and this is like also important part of the module. So as an AVS, you can submit the reward claim to Exocore network. That is, Exocore sends that reward distribution back to the actual L1. Before all this happens, permissions granted between the client contracts. And then there's a call to issue the reward tokens, and then those tokens are claimed by the restakers. So this is a pretty straightforward flow. So where do rewards come from? So they can come from third-party tokens, obviously ETH, kind of native tokens, USDT, stablecoins, a variety of different tokens. If the AVS has a token in circulation, they can elect to increase the inflation or adjust the inflation, pay the rewards with those fees. Obviously, this is contentious. Being part of a community and hearing that inflation is going up is usually not a good thing. Half the community wants it, the other half doesn't. Fighting, bad things happen. And then finally, transaction fees. You can actually use a portion of transaction fees if you do charge transaction fees to pay for the cryptoeconomic security. But what if I told you there was another way? So we came up with a novel mechanism called union staking. So union staking is basically, think of, okay, you're an AVS, the rewards, the limited way to pay the fees, maybe you have minimal resources to be able to allocate. That's okay. So we came up with a way that you can actually, an AVS can join a union of other AVSs, effectively pooling their restaked asset to combine it and share the asset. This is kind of a little bit of like a cross between mesh security and shared security. I won't get into the minutia of what the differences are, but we've basically taken a little bit of both and applied it to this model. I think this is going to be really powerful because it allows AVSs to rent the cryptoeconomic security without having to kind of go into their pockets. There's a lot of analogs for this, like in the insurance world, the reinsurance world. So we think that this could be a powerful design to allow AVSs to kind of help secure themselves. So in summary, bootstrapping cryptoeconomic security sucks. Trust me, I know. You can actually rent cryptoeconomic security now before you buy, and rental rates are dropping due to union staking. So if you want to check out more, like I said, we just published our white paper yesterday. We've been working on this for many months. We've taken a lot of years of operating in this industry to kind of go into the design, and looking forward to talking more. Thank you.
Have any questions for Warren? One, maybe. One to start.
You asked the other guy a question too.
Exactly.
He's the question guy. I like questions too.
Yeah, because I'm basically like doing Degen DeFi stuff, and I was wondering, we all know about liquid staking. What are your thoughts about the idea of leverage restaking with a liquid restaking? How far we go with that? With liquid restaking, or with liquid restaking?
I know it's Inception, right? So I was gonna add. I think we've converged on LRTs officially. By the way, the switch from LSD to LST happened like insanely fast. I've never seen that was very, yeah, all the lawyers agreed at the same time not to say LST is LST, okay. So anyway, LRTs are basically liquid restaked tokens. Now this is an interesting phenomenon. It's kind of expected. There's going to be a lot of, I guess, financialized kind of applications and assets built on top of restaking. I think I won't speak for Shriram, but I think it's one of those, just lean into it. Let's research the downsides, but I think the market's going to pick it up very quickly. I think there's opportunities to support all LRTs. And I think, Shriram has said before, and I agree, you can basically, everything you can do with liquid staking tokens and liquid staking token platforms, you can do with restaking. So there's nothing materially new here with at least the token form. But what is new is that restaking is designed to solve that problem of bootstrapping decentralized security and trust. So we think that at least the intention of the protocol is just to solve the problem, not just to stack yield and ape into everything. But that tends to happen. So there's a lot of precautions that we're kind of employing and risk mitigation kind of building into the network, including doing lots of your classic auditing. Beyond that, we're exploring potentially doing like insurance pools. We like the idea of potentially diverting, of some of the fees into like a SAFU type fund that can go toward, hacks or slashing or anything like that. We think that's an important piece of the puzzle. And then, so these are like things you can also prevent some of the slashing. These are the kind of downside risk by running things in like trusted execution environments and kind of focusing just on the slashing details. So this is very new. I'm excited. I've been in operating space for 10 years, and like I still get out of bed every morning very excited to work on this stuff. Just keep connected. We're very early, like I said, so happy to hear lots of feedback.
Great. Any other questions? Anything else? All right. Well, listen, let's give Warren a hand, especially for making it quickly to sub in. Last hand for Warren, please. And I have good news and bad news.
And the bad news is that Carton, who Warren took his place, is no longer making it. So he's stuck in traffic. He may be in Asia, for all I know, on the Asia side anyway. So we don't have Carton, and so Warren was our finale. So yeah, you could have really got, so Warren, and we were going to finish with a panel, but we don't have Carton, and we think it's been a long day, so we don't want to wear everybody out here. So I think we are going to move on and call a day and thank everyone for all your participation. Thank all the sponsors for their help in putting this together. And again, thank Nadia, who orchestrated, designed, and produced this event. So round of applause for Nadia, please. And when you see her, give her a high five. And again, thanks everyone for coming, and hope you had a good day and are staying in touch with the panelists and took something away from this day. Really appreciate it. Thanks again.